So now I get to introduce our first keynote speaker, Dr. Marty Ralph, Director of the Center for Western Weather and Water Streams at Scripps Institution of Oceanography. I've had the good fortune of knowing Marty for over 15 years now and collaborated with him in efforts to improve observations and forecasts that can improve and provide more information for water management. Knew Dr. Ralph when he worked at NOAA's Earth Systems Research Lab in Boulder, Colorado, and was very excited when we got to have him here at Scripps and build the partnership that we have today. So, Marty, I'll yield the floor to you for your first keynote.
Good morning. All righty. It's a real honor to be here and to see this beautiful facility, this room, the building. It inspires a sense of importance that the Natural Resources Agency genuinely has and Department of Water Resources. So with no further ado, let me dive in. Let's go to the next slide, please. California, by its nature, is a land of extremes, and it's getting even more so. And go ahead. One of the key illustrations of that is from how it has to do with how variable the annual precipitation is. I'm from Michigan originally, lived in Arizona, Florida, California, Colorado. The year-to-year variability here is just remarkably greater than anywhere else in the country. And those green and blue dots represent that. This is from a study some time ago. Go ahead. And there's been an update to that adds another 25 years of data and shows the same sort of result, different style graphic. And let's see how that changed in the last 80 years. Go ahead. It turns out that that variability has increased. Those blue areas represent where the role of a few big storms each year has increased over time. And go ahead. All right, we got to get the advancing thing going here, right? So I'm going to use my finger. If you could advance it when I raise my finger so I don't have to say words, that'd be great. So this is a remarkable illustration from Mike Dettinger that shows how California, once again, is so unique in how precipitation arrives in this state. You see all that gray area is where, just the top 7 days each year produce, 50% or so, maybe 30% of the precipitation annually. Here in California, we have places that get something closer to 70, 80, 90% of the precipitation we get for the whole year comes from these storms. So next, please. What is the type of storm that creates that? It is going to be what we all know already is atmospheric rivers. But an atmospheric river is part of a bigger storm, often, not all the time, but called an extratropical cyclone. And this is a super strong version of one called a bomb cyclone. And most of meteorology historically over time has focused on that low center, at the center of that coiled spring. But what we've learned in the last 15, 20 years from science and study and testing is that there's a particular part of that storm that is super important for us. More important, actually, than the low itself is this area down there in blue, which is where the water vapor is, and that's the atmospheric river. Those white lines are called streamlines to give you a sense of the flow direction. And that flow is coming from the southwest right into the state, carrying massive amounts of water vapor. In fact, any one of those ARs, as we call them, atmospheric rivers, can carry as much as 25 Mississippi rivers worth of water. They're about 500 miles wide, maybe 1,000, 2,000 miles long. You see a satellite image there on the right of one that's going from the southwest to the northeast, and that's the water vapor in the atmosphere we see from satellite. You see the schematic on the left is from a Scientific American article about 10 years ago by Dettinger and Ingram. And fundamentally, these storms produce both the major water portion of our water supply, but they're also the cause of floods. An example of that, sadly, was about a year and a half ago. We had a big AR storm, an AR3. I'll come back to the scale in just a moment, that produced debris flows after wildfire. This is one of the big risks, also relatively unique to California, is this incredible combination of fire and flood. And it can be, a very deadly thing like happened in Montecito near Santa Barbara a few years ago. Over 20 people lost their lives in one of these storms and the associated flooding after a big fire. Go ahead. And it turns out that this was one of the billion-dollar disasters in the state of California, or for the nation, in 2021. But in addition to producing that incredible amount of rain and debris flows, go ahead. You see the fact it also produced a huge amount of snow. In fact, about half of the precipitation, snowpack wise, in Central Sierra came that year. Half of it came from this one storm. One storm. Without that, I can't even imagine what the water year would have looked like. But at least we had this one to help us out. So it comes with both, problems and benefits. Go ahead. An example of a product we've developed with DWR support and inspiration actually is a map of where atmospheric rivers hit land. And this one is from January, February, and March of 2019, which was a wet year. Each one of those arrows represents a different AR. And if we go ahead to this last year, look what happened. We got essentially none. And the color fill on the continent is the anomaly in precipitation. Notice the blues on the left, that was a super wet year. And the reds on the right, that was last year, extremely dry. So visually, it really instills this finding from the science now that basically ARs make or break the water year. We get enough and we're okay. We get too much, we can get into flood, and we don't get enough and we end up in drought. And that's the story of climate here in California. That's one of the punchline takeaways from this briefing. Go ahead. We've also calculated the impact on flooding, or the role of atmospheric rivers in flood. And this is from a paper by Corringham et al. A couple of years ago. And those dots and the numbers by them represent the percentage of total flood damages over 40 years from FEMA records that were associated with atmospheric river storms. And you can see in the Northwest and along much of the California coast, it's 80, 90, even 99%. Essentially, these are the flood makers for much of the West. And in fact, if you look at the whole total in the period of time we were looking at here, 40 years, 84% of all flood damages in the Western US were from ARs. And if we, because these storms can be both beneficial and hazardous, and the public was learning through the media and the National Weather Service about atmospheric rivers, there's an AR coming, was in the news sometimes, and people didn't know whether it was going to be a big one or a small one or what to make of that. So there was a request, essentially, a need emerged to develop a way to distinguish the big sort of damaging ones from the ones that might be more beneficial. So we invented this scale at our center, and it essentially has two variables. One is the strength of the AR at a given moment as it passes overhead, and the other is how long it stalls overhead. It's pretty intuitive. If a storm stalls longer, it's going to have a higher impact risk in terms of flooding. And you can see the rankings there in the color, 1 through 5. It's essentially our version of a hurricane scale, but we call it AR rankings, AR 1, 2, 3, 4, and 5. Now, look at that data from the left there. Go ahead. And you'll see when we take the flood data, the flood damage data, we can actually ask what ranking was the AR that was related to that flood damage. And we see it on the right there now scaled. It basically goes up by about a factor of 10 once you go from AR 2 to 3 to 4 to 5, with the median damages being on the order of $250 million for an AR 5. These vary when the land it's hitting is not populated, there's not much built environment, or it's early in the season where the soils are super dry and can absorb a bunch of the original part of the rainfall. But if it happens, maybe an AR3 happens right after an AR4, that AR3 can produce massive damage because it puts the rivers over the bank. So on average, it scales by a factor of 10 essentially with each level. Go ahead. But we see in the AR1s and 2s, go ahead, that it's really mostly beneficial. There's really almost no damages with those, a couple hundred K on average. Go ahead. And you see the AR4s and 5s are really the ones that can deliver the big punch more normally. So this is now part of our situational awareness environment. People can look to this scientific finding, this tool, to better understand what the nature is of the storm that's coming or of what just hit. Go ahead. All righty, let me turn to the question of change through climate. And I want to highlight a couple things here. Go ahead. First of all, droughts are becoming worse. This is an analysis by Mike Dettinger on the Russian River, the north coast of California division. You see the map on the upper right there with the star. And this is going back 80 years, and it's looking at the Palmer Drought Severity Index. The farther down that black line goes, the more severe the drought is. And it doesn't take a statistician to tell you that things are getting, droughts are getting worse in this part of the state. And this is sort of representative of what's going on in other parts of the state as well. And some of these things are just staring us right in the face. This is underway. This is now. We're not talking about, someday in the future this might happen. It's happening. Go ahead. And one of the reasons it's happening, you can ask with the drought, and this index is sensitive to both precipitation and temperature. Is the precipitation decreasing, or is the temperature increasing, or some combination? This dot diagram on the right, basically the fact that those red dots, which are the most recent years, are to the right of the black dots on average, is telling us that the change is largely because of temperature. There's been, and the warmer the air is, the more it can suck water out of the landscape. And that can contribute in this Palmer Drought Severity Index to a bigger number, an anomaly, and a worse drought, essentially. So we see this change already is underway. Go ahead. Let me skip that one. What does this mean from a pragmatic standpoint is illustrated here. The current situation is, you can see the size of the font really is the message. We have drought switching over to flood, and those changes can happen very quickly. And we can have drought right after flood. We can have flood right after drought. It's sort of a mixed bag. Just because we're in a drought doesn't mean it's going to end by a flood. Just because we're in a flood doesn't mean it's going to end with a drought, but it all can happen. So we've got different sequences. But the thing that the science is telling us is in the future, droughts are going to be deeper and floods are going to be bigger. And the normal is going to shrink in terms of the amount of time that we spend in the space that we would call normal. And this is a really sort of intuitive visualization of that shift. Go ahead. The current drought is remarkable in its duration, 3 years now. And it's summed up on the left here with a diagram that shows all the ARs that were strong or greater. That scale has weak, moderate, strong, extreme, exceptional. So just the top 3 rankings. Look how the vast majority of them are in the Pacific Northwest and very few in California. Normally we would have more than that in California. The middle panel is about the precipitation deficits. If you add up the offset in precipitation from normal over the 3 years compared to 1981 to 2010, those yellow areas we're more than 1 year behind over just a 3-year period. That's a serious deficit. And that's part of where our problem's coming from. You can see even some areas are orange, more than 1.5 years of deficit. And on the right is a diagram where we look at evaporative demand. That's essentially the heating of the atmosphere, the warming of it, and it's not carrying, it can carry the water vapor out of the soil from the plants largely and suck it out so that it's going to take more rain, more portion of the first rain in the fall to remoisten the soil and produce the runoff into the rivers and reservoirs that we need. That color scale on the right is the ranking of historical years from 1 to 40. And you can see all that black area means it's the most extreme of all 40 years in this 3-year period, number 1. So you can see a vast majority of California has been impacted in this way by a lot of loss of water from the soil through evaporative demand. And it's also behind, we're also behind on precipitation. Go ahead. Well, what's coming in the future in terms of ARs is quite interesting. And this is really a paper about precipitation. And this is from Gershenov et al. And it shows that those blue areas represent increasing percentage of total precipitation that's due to atmospheric rivers. So you can see that we're already in parts of the state, like half of the annual precipitation is from ARs. This is saying that's going to increase substantially as we go forward through the rest of this century. Go ahead. And this diagram on the right, basically each bar chart represents a different, how heavy the rain is. Is it a dry day or just a little rain or a moderate amount of rain or a lot of rain? And those top right two panels are the greatest 90%, greatest 10%, or the greatest 1%. And the fact those bars are tall means a vast increase in the amount of precipitation that's going to come from the top 1% biggest storms. And that means that, essentially more extreme events are going to occur more often, and they're primarily caused by ARs. This is what the climate models are telling us with really very little doubt. Go ahead. On the temperature side, and I want to thank Dave Pierce for this, we have increasing temperatures in Sacramento and Los Angeles here under climate change. The horizontal axis goes out to the year 2100, starts in 1960. And you can see the count of the mean annual number of days per year exceeding a temperature threshold. Let's take the 100-degree Fahrenheit one on the left. That's Sacramento. And you can see around 2000, there's maybe 10 or 12 days a year. And by the time we get to 2060 or so, it's about 50 days a year. And you see it goes up from there. These are dramatic changes in the temperature. And this is part of that evaporative demand formula that says we're going to lose a lot more water vapor from the soil because of this. Go ahead. All right, now the punchline of this talk really is about there are a lot of things underway right now to bring science to bear on these problems and to find and invent solutions. Think of that as a science to solutions sort of framework. And we've been at this, scientists and Department of Water Resources has been a major sponsor and has led the charge in some ways, along with partners at local water agency level and federal agencies. And I want to share a few of these. Go ahead. First is what I'll say organizational innovation. And this is our center at Scripps. I wanted to mention Center for Western Weather and Water Extremes. I came here in 2013 to start this, to give special attention to Western water needs, in particular California. And here we have an illustration showing the different components of our center. We're really here to try to innovate on the understanding of the storms and the climate and the precipitation and how that information can be used to improve decisions and increase resilience. Go ahead. Ahead. And one of the key things we've invented with a lot of partnership with the U.S. Army Corps of Engineers, DWR, local water agencies, is what's called forecast-informed reservoir operations. On the left, we see a typical scenario. This is a reservoir we demonstrated, FIRO, forecast-informed reservoir operations, Lake Mendocino on the Russian River with Sonoma Water Agency. And on the left, you see the water year, essentially, most of it there, and the storage in Lake Mendocino, which is on the Russian River. And the blue area is this major deviation buffer zone that we tried out with the Corps, where normally, go ahead, when a storm hit, that red curve would be what would happen. Essentially, the water that came in from the storm would be released quickly to retain the flood control space that's needed. But if we knew that there's no storm coming for a few days, no big AR, then you could keep that water for an extra day and safely do so, and then look at the forecast the next day. And if you have a few days lead time, you'd then have enough time to release that extra water you kept after that storm earlier. And here's what we see happen, that black curve. Instead of it being released, it was retained because we were trying out this FIRO effort with the partnership between the Corps of Engineers and Sonoma Water. Go ahead. And that led to about 20% additional storage in that reservoir going into what was in the third driest year on record. And that's enough water for several tens of thousands of households for the year. So this is an example of a demonstration of FIRO in the water supply reliability enhancement arena. We're now working with Orange County Water District on Prado Dam, with Yuba Water and the State Water Project on Oroville and New Bullards Bar. We're also exploring this in other parts of the West. There's a lot of interest in this topic, and really appreciate the support from DWR for our work at the center, which sort of helps make sure the forecast, the F in FIRO, is as good as it can be. Go ahead. Go ahead. So that's a reservoir operations innovation example. Keep going. In addition, we've got a scenario we're exploring right now, developing the concept, this FIRO 2.0 space, the green on the left there. Is meant to mean if forecasts improve in skill, we would get greater lead time, and therefore that should translate potentially into more flexibility in operating the reservoir. Go ahead. And essentially the math here is simple. The better the atmospheric river forecasts are out to several days to a week or two, the more flexibility is likely to be possible, more for reservoir operators safely to keep water after a storm or to pre-release ahead of a big storm. So this makes the tie between advancing prediction and better water resiliency. Go ahead. We're going to jump ahead pretty quick here. There's a set of actions that are underway. I'm going to just sort of headline them. We now have new observing offshore of ARs. It's called AR Recon. I led the development of that in our center, and we work with the National Weather Service. And these data are flowing now each winter when we fly into the forecasts that we're using operationally. Go ahead. We fly aircraft from the Air Force and from NOAA, and we increase the lead time on that storm. I showed the picture with the terrible debris flow. We increased the lead time skill from 2 days to 5 days by adding these data out over the ocean and assimilating them into the operational model. Go ahead. And that's an example of observational innovation. Go ahead and just step through the next bit here. We are improving a model. The lines going down there in color are improvements over the last few years with our center's work on a specialized model for the West. Go ahead. Go ahead. Go ahead. And also the scale that we've developed is being used by the media, so there's increased situational awareness. Go ahead. Go ahead. And sometimes it shows up on the your local newscast. Go ahead. And there's a story I want to let you know about in Scientific American just last month. I'm the author of it, and it's essentially about the science to solution story of developing the AR scale, AR recon, forecast informed reservoir operations, and the like. Go ahead. Go ahead. Go ahead. And also want to highlight the fact that all this work is really done in the form of partnerships and collaborations. Go ahead. That bring people together from different disciplines, from different organizations with different backgrounds, a very diverse group of people. You can see this is from our FIRO workshop at Scripps last summer. Go ahead, and this will be the last, second to last slide. Go ahead. Essentially, the state of California through DWR and its Natural Resources Agency and leaders all the way up the chain are really demonstrating leadership that is something to build on, innovations and leadership. And then the last slide is a couple of things to advance real quick. This is a state that has the most variable precipitation annually anywhere in the country. It has extremes in wet and dry and heat that are increasing with time. Drought and flood follow each other. Go ahead. And then atmospheric river science and predictions tailored to California can really help support forecast informed reservoir operations. They enable it. Go ahead. And then finally, I just want to really highlight, and this is a very personal thing for me. I moved to California from Colorado and NOAA, particularly because of these factors. California is into innovation. Science, innovation, and collaboration are central to the success of what we've been doing. I believe it's central to the future. And I thank DWR for your leadership in this arena and enabling those of us in science to try to do our part to help the state deal with these increasing challenges. Thank you.
All right, now we get to transition to our next keynote speaker, who will be joining us virtually from Colorado. So hopefully he'll appear on the screen there momentarily. Maybe. All right, well, I'll introduce him while he hopefully makes an appearance here and we get the transition going. Dr. Daniel Swain is a climate scientist in the Institute of the Environment and Sustainability at UCLA. And you have often seen his work in blogs, tweets, and posts on extremes, climate change, and what we are experiencing. He is the author of the Weather West blog, providing real-time perspectives on what we do. There he is. Hey, fantastic. Dr. Swain and I have had the opportunity to work together, revisiting. Hopefully that clears up. But Dr. Swain and I have had the good fortune of collaborating on a project that looks at a scenario of an extreme. And with that, I'll turn it over to you, Dr. Swain.
Thank you, Mike, for that introduction. And, I actually think that Marty's presentation really provides a great overview of my own perspective. So it's a great lead-in for what we're going to talk about here. And oops, looks like these slides are advancing magically. All right. I'll cut right to the chase, which is great because, again, Marty really set the stage here. It's not so much the change in California's overall average precipitation that we're particularly concerned about in a warming climate. It's actually everything else that's probably going to be a bigger problem. So when it comes to precipitation, even though we haven't seen a large decrease, for example, in the annual average precipitation to date in California, we are starting to see other changes when it comes to precipitation. And so when we look at climate model predictions, let me make sure I can control this here. There we go. What we really expect to see is a large increase in the intensity of precipitation when it does occur, but a decrease in the frequency of precipitation. And this is directly in line with some of the figures that Marty just showed, where essentially we lose a lot of the light to moderate precipitation that is almost exclusively beneficial when it has occurred historically. We gain a lot of high intensity precipitation that can still deliver much needed water, but then also start to pose the problem of causing hazardous flooding or other geophysical hazards, because the intensity above a certain point can do more harm than good. And all of this, I'll remind folks, is unfolding in an environment where we have not seen a large change in California's overall average precipitation, and don't necessarily expect to see a large change in the region's overall annual precipitation. But that really belies some really dramatic shifts, both in the temporal and intensity characteristics of the precipitation that will occur, as well as the overall drought picture when it comes to, again, as Marty mentioned, that increase in evaporative demand from the rising temperatures themselves, which is extracting more and more water from the landscape. And we've seen a lot of examples of this recently. This is no longer really some abstract prediction about the future. California is, of course, as we've already heard, a place that is intrinsically, geophysically susceptible to extremes of hydroclimate on both sides of the spectrum, drought and flood. And normal sometimes feels like it's something that doesn't happen very often. And as much of a joke as that may sound, there is some mathematical truth to that too, where the frequency that California actually has a precipitation close to its mean or its median is not as high as in other regions. And that's another way of interpreting those variation plots that Marty showed earlier as well. But in the recent context, just drawing attention to a very hydrologically significant part of California, Butte County and Lake Oroville and the Oroville Dam, just over the past decade, we've seen some really dramatic swings back and forth. And I really, what I want to emphasize here, it's not just in one direction, but rather in both directions, much as we've been talking about. We had that extreme and historic, at that point, drought in 2014 and 2015. We saw the dramatic images of Lake Oroville, very low, lots of exposed soil there. But then pretty quickly thereafter had the opposite problem, and we had what was essentially the wettest winter in modern history in parts of Northern California. That was the year we experienced all the trouble with Oroville Dam and narrowly averted a much worse outcome than ultimately occurred. So that was a year of too much water up north. And now we're right back into the scarcity, another extreme scarcity period just a few years later, where we're at another drought that is of comparable severity to what was the historically severe drought just a few years ago. So, we've seen certainly in Northern California, this pretty dramatic swing. It's been more drought than flood recently, but we have actually seen pretty dramatic examples of both, lest we forget the other end of the other side of the coin there. And of course, as has already been mentioned, California is no stranger to these sorts of swings. But what we're seeing, as illustrated specifically by just this one piece of critical infrastructure, or Oroville Dam and Lake Oroville, which is an important piece of California's overall water supply, is that the climate that we're seeing and the climate extremes that we're seeing recently are starting to push this infrastructure to its limits, and in some cases beyond. And so what's going on here, and I won't belabor the point too much because we've already heard this, but how are we possibly seeing such an increase in severe drought despite the fact that precipitation really isn't decreasing much on average? Well, it really points to the fact that precipitation only drought metrics, and we do use these still in some circles, are becoming increasingly misleading in a warming climate. So I would strongly advocate that we move beyond simple precipitation only metrics, because they aren't really going to tell us anymore how much water is available and how severe the drought that we may be experiencing actually is. Part of this is really just because the same amount of rain and snow that falling from the sky just doesn't go as far as it used to. And this isn't a statement about water demand by humans or agriculture or cities. This is just a purely physical statement about more water re-entering the atmosphere simply because of that increased evaporative demand from rising temperatures. So if roughly the same amount is falling from the sky, but more is evaporating back into the air, then there's going to be less to go around at the surface where we care about it and where ecosystems actually care about it. Part of this is coming not just from the increase in temperatures alone, but from shifts in the temporal and intensity characteristics of precipitation. So as I mentioned, we are seeing and expect to see much more dramatic shifts in this direction in the future, a shrinkage of California's already relatively short but sharp rainy season. So we currently have obviously a rainy season that peaks in winter and comes almost to a zero minimum in summer, where really there isn't much hydrologically significant precipitation in most of California during the warm months. We expect that seasonality to become even further amplified, where now even the shoulder seasons, the autumn and the spring, when we sometimes receive meaningful precipitation, sometimes not, we expect to see even less meaningful precipitation in those shoulder seasons. So both a longer evaporation season and more intense but shorter bursts of precipitation during the wet season that does occur, which will of course still be during winter. So we expect to see more precipitation during the most intense storms, but fewer days of precipitation even during the wet season. And so essentially we get this increase in this precipitation whiplash effect that I mentioned, not just from year to year, which we're sort of used to, but increasingly from season to season, where the dry season and the shoulder seasons get even drier, but the already wet season might actually get a bit wetter because these increasingly extreme atmospheric river storms, at least at that time of year, are likely to win out. And in addition to that, we have this decrease in snowpack, of course, because it's warmer. We have less spring snowpack. We have snowpack that melts earlier in the season. And critically for flood risk, and since I'm really going to focus on that for the rest of the talk, that snowmelt is happening closer to the time when we're actually getting these extreme precipitation events. So if you have snowmelt that occurs several months after the peak wet season, you might not have an alignment between that really intense precipitation and that really intense snowmelt runoff. But increasingly in a warming climate, we're going to see both of these things overlapping, happening simultaneously in a way that is probably going to increase flood risk by much greater margin than just the projected increase in the most extreme storms alone. So all this put together, this is, and again, echoing exactly what Marty already emphasized, we expect to see a significant increase in both drought and flood severity in a warming climate. We're not headed just in one direction, but we're heading sort of in diverging directions in different years and in different seasons. And this is not something that is inconsistent with climate models. This is in fact exactly what climate models suggest should be emerging right around now and continuing to amplify through the century. So my main point of the talk here today, and I guess I'm running a little bit behind, I have less time than I realized I had apparently, so I'm going to run through this really quickly. But California has a long history of extreme floods, but not so much in the 20th century. So if we go back to the previous century, the Great Flood of 1862 is the benchmark event. We had some recent work suggesting that the climate change would probably be increasing the risk of an 1862-like flood quite significantly, but we really wanted to dig into that more deeply because there's a lot of evidence that in a warming climate, California is going to see stronger and moister atmospheric river storms. And Marty's already done a great job discussing what those sorts of storms are. And the long story short is really just that in a warming atmosphere, the water vapor holding capacity of the atmosphere increases exponentially, even for linear warming. So you get a really rapid increase in the possibility of the very most extreme events preferentially, leading to the potential for unprecedented individual extreme storm events. And so what we've done in recent months, as Mike mentioned in the introduction, is take a look at the specific potential and the impacts of this sort of event in a new project called ArcStorm 2.0. There was an ArcStorm 1.0 about a decade ago. What we've done now is sort of use some recent scientific advances and increase knowledge about climate change to really revamp this scenario for the 21st century and explicitly include climate change. And I want to talk about just some of these results briefly right now. Having some lagging issues with the, all right, well, I guess I can't, unfortunately, this is one thing that I guess I can't control that animation, but I'm running out of time anyway. Essentially, what this animation would show is a very long sequence, a weeks-long sequence of individual extreme atmospheric river storms. So not just one extreme AR, as already mentioned, but a whole month-long sequence of 10 or even 15 of these events. And as these evolve, this scenario is therefore designed to accommodate not just a single event, but a sequence of them, which essentially increases the potential for flood, because we might be able to handle the first 1 or 2 events okay, but once we get to event 5 and 10 in the month, we start to really run out of room in the system to store any more water. And just trying to advance here. This is what the picture looks like in terms of the scenario that we designed for the present era on the left and the warmer future era on the right. And what I really want to emphasize here is that both of these scenarios bring a phenomenal amount of rainfall and in some cases snow to California on the order of feet. But the future scenario brings considerably more water in that 4-week period than the historical scenario. So both of these would produce widespread severe flooding, but the future scenario, it would be even more substantial. And in a warming climate, as I mentioned, it isn't just a question of the increase in the most extreme precipitation events, but it's also a question of the warming itself and the influence it has on melting snowpack. So we see a pretty dramatic shift from liquid rain, toward rain from solid snow. So instead of getting a nice gradual accumulation of snowpack that might melt later in the season, in the spring and summer months, we get a smaller snowpack that is more liable to melt during the storm event itself, contributing quite substantially to runoff. And this means that even though we see overall about a 40 to 50% increase in the most extreme precipitation during this 3 to 4 week sequence in the future relative to the past, there are some hydrologic basins that we actually project a 200 to 400% increase in the maximum runoff. And that huge difference between the precipitation increase and the runoff increase mainly comes from that increased runoff from water falling as liquid rain rather than accumulating as snow at higher elevations. And so California really is the climate change really is increasing the risk of a mega flood in California. And in this recent work that you may have heard about this summer, we really wanted to quantify this explicitly. And we found that climate change has probably already doubled the risk as of this year, even though we haven't seen one in a long time. This is a risk that has been increasing latently, quietly in the background. And so this is one of the hazards of maladaptation, essentially, in a warming climate. We've experienced so much severe drought, so much water scarcity, so much wildfire recently. I think we ignore the increasing flood risk at our peril. I understand why we've been doing it to a certain extent. It's been sort of out of sight and out of mind. We just haven't had a whole lot of recent experience with it. But this is something that we're going to have to really grapple with in the years and decades to come, because the cumulative risk of a potentially disastrous mega flood in the next 40 years or so is almost 2 and 3. So more likely than not at this point. So I'm going to really run through these final slides really quickly, but what would a modern mega flood look like? Well, it would be a large disaster on the order, or probably larger even, than the impacts from a large magnitude earthquake near Los Angeles or San Francisco. There is no modern precedent for a recurrence of an 1862-like flood. And California's flood and water, infrastructure was built for a 20th century climate that no longer exists. So there are major questions about how it would fare. And this is something that we're going to be exploring in future phases, ongoing phases of the ArcStorm 2.0 project. But in the original ARC storm scenario, it was estimated that the total losses in California could approach $1 trillion in 2022 dollars. So that's trillion with a T. So we're really talking phenomenally large numbers here, along with millions displaced for extended periods of time, transportation infrastructure severely disrupted, and essentially all economic sectors affected simultaneously. So how do we adapt to this? And I won't spend really much time on this because Marty already introduced some of these concepts, but really ensuring, first of all, that our existing hard infrastructure is up to the task. That is an important question, but also thinking about how to greatly expand our soft infrastructure. So thinking not necessarily building more dams, higher flood walls, but also how can we let the water do its thing in a semi-controlled fashion through things like levee setbacks, river bypasses, think the Yolo bypass on the Sacramento River, and floodplain restoration, which has a lot of other environmental co-benefits as well. Things like forecast-informed reservoir operations are going to become really critical in successfully managing both drought and flood, as will managed aquifer recharge. And we may even get really fancy and do things like forecast-informed managed aquifer recharge. If we can pull that together, that would be great. And ultimately, I think that just to close with a few final thoughts, obviously, this kind of flood event, it may feel like it's coming out of left field, but geophysically, it's not. This is a part of the world that is susceptible to these. We know that from the paleoclimate record. We know that from the deep historical record. We've even seen some recent tastes of the kinds of extremes we're talking about, but we haven't seen 5 or 10 of these in succession. And so that's the kind of scenario that we're most concerned about. Much larger storm sequences and therefore floods than were observed in the 20th century are highly plausible in California, not just because of climate change, but also in general. We haven't seen the worst of what Mother Nature can throw at us in recent years, whether that's because we've gotten lucky or for some other reason. Eventually that luck is going to run out, especially because climate change has now doubled the risk of severe widespread storm sequences capable of causing severe flooding in California. And we're currently continuing to work on this ArcStorm 2.0 project to flesh out the details of what this would actually look like in California. So if you are interested or are interested in participating in this project, please do reach out. And much can be done to mitigate these risks, but we have to do it. And the name of the game is going to be flexibility rather than rigidity. And we're really going to have to co-manage the risk of droughts and floods in a warming climate. So with that, I think I'm done. And thank you for listening.
Thank you, Dr. Swain. Appreciate you taking time to join us virtually. Thank you very much. At this time, I'd like to invite panel 1 to come take the stage. Have our panelists take a seat at the desk there, and I will introduce our moderator, Bianca Sievers. Bianca is DWR's Deputy Director for Special Initiatives. She works to implement the department's human right to water policy and builds and strengthens partnerships with vulnerable communities and environmental justice organizations. She is instrumental in aligning the department's strategic thinking and actions related to the water resilience portfolio, DWR's strategic plan, and organizational health efforts, and has been a policy advisor to Director Namath since 2018. Bianca, the stage is yours.
Can you all hear me? All right, as the logistics to the panelists, I've been told that we need to mute our mics before we speak, or if you're not speaking, please keep them muted. All right, thanks all. It is my pleasure to introduce this panel today. I'm going to start from the right of your screen today with Ivan Senok. Ivan Senok is the Tribal Historic Preservation Officer and Cultural Resource Director that oversees the protection of Buena Vista Rancheria of Miwok Indians' heritage and cultural resources in the ancestral territory of the tribe. Ivan's professional research focuses on the lived experience of California Indigenous communities and their intimate connections to landscape. Additionally, he teaches archaeological monitoring and documenting oral histories for tribes in Northern California for heritage and cultural practice restoration. Next, you'll meet Dr. Mark Strudley. Dr. Mark Strudley is the Executive Director of the Pajaro Regional Flood Management Agency, a joint powers agency, overseeing capital investment and operations and maintenance for flood risk reduction solutions in the Pajaro Valley of Santa Cruz and Monterey counties. He is also the Flood Control Program Manager of the Santa Cruz County Flood Control and Water Conservation District, Zone 7, the Pajaro Storm Drain Maintenance District, and leads flood control activities throughout Santa Cruz County as a division manager in the Department of Public Works. And then we have Justine Massey. Justine holds degrees from Stanford University and UC Davis School of Law. As the policy manager and attorney at the Community Water Center, she works alongside residents to protect drinking water for disadvantaged communities in the Central Valley and on the Central Coast. And she focuses her core strategies to include sustainable groundwater management, drought resilience measures, nitrate management, and climate change adaptation. And then lastly, we do have someone on line with us. It's my pleasure to introduce the Mayor of Huron, Ray Leon in Fresno County. He works to improve quality of life for the residents who mostly are composed of hardworking, low-income farm worker families. He is also the founder and executive director of the San Joaquin Valley Latino Environmental Advancement and Policy Project, also known as Valley Leap, a nonprofit organization focused on environmental and transportation justice, air quality, climate change, energy, green jobs, and community development. With that, let's give our panelists a warm welcome for being here with us today. Thanks, everyone. I know we need to get a little movement in the morning. So thank you so much. Starting with this panel was an intentional decision by the department. I think this panel represents the community perspective on the ground. And as the director mentioned, this event is all about partnership. And when we think about who are our partners, it's essential that we continue to elevate the perspectives of community members and community leaders who have expertise of the communities that they reside in. So really excited to kick off this panel today. Dr. Ralph and Dr. Swain, they provided some intensely eye-opening information today. And, I think one of the graphics that really stood out to me was a simple but powerful graphic that Dr. Ralph shared with us, which was an arrow with a circle, arrow on two sides and a circle in the center. We had drought, and we had flood, and then we had normal. And if you all recall, normal kept shrinking, but flood and drought on either side kept growing. And to me, that is kind of the scary reality of our future. And Dr. Swain listed that phenomenon as kind of an intense whiplash. And so I really want to kick off this conversation today with putting this all into perspective of how these extremes are impacting our people and communities on the ground. So Justine, the Community Water Center is focused on several initiatives that help vulnerable communities access safe water resources. Based on your work, how are communities adapting as they navigate longer dry periods, juxtaposed with severe precipitation and flooding?
Thanks, Bianca. So first and foremost, communities are trying to survive. We work with disadvantaged communities or underrepresented communities because they're the most vulnerable. That's not an accident. That's a result of historic actions and inactions by different groups. But really, they've been pushed to a place where their everyday survival is at risk. So when we talk about resiliency with increasing challenges due to climate change, we're also talking about resiliency within current conditions is already a challenge, a real everyday challenge. So that means trying to maintain water supplies that already exist. In particular, the human right to water is very challenging for 1 million Californians who do not have access to reliable, safe, clean, and affordable drinking water today already. That is worsening rapidly also. Even where the state and technical assistance groups are intervening with those Californians who don't have access to safe drinking water, you can barely keep up. Conditions continue to worsen, particularly with groundwater as it faces so many threats, depletion, in part due to drought, in part due to continuous overuse, basically since we started drilling wells in California, and pollution from many of our different land uses, in particular, unfortunately, agriculture due to nitrate really complicates drinking water and can make it poisonous. So the organizations that are trying to provide replacement water for people who have already lost access estimate that at this point, it would take 20 years to secure long-term solutions for the 1,600 households that they know of today that need those solutions. And every year we see more and more wells going dry. So what that means for individuals is adjusting to, instead of being able to get water out of their taps, they're waiting on bottled water delivery, or they have large tanks in their yards that get filled up periodically. That's very difficult, let alone thinking about what would happen if any of those already precarious emergency systems got further displaced due to a large flood event, right? What if the transportation falls through? What if the tank or even the bottles themselves got contaminated by flood water that passed where wastewater is? So the resiliency of these communities is really in question. And we need to direct our resources into ensuring that they can weather the weather, that they can handle the extremes that we know are coming down the line, particularly because we're advancing so much in anticipating what this will look like. That means that we also have the responsibility to react, right? It's not an unforeseen emergency anymore. It's what's coming up ahead. And just a final thought on this. These are our frontline communities, right? That those words get used a lot. These are, in many cases, farm workers. They're the essential workers who continue to work during the pandemic. We rely on them for our economy, for our food. So this is not a dispensable portion of society by any means. Yeah.
Thanks, Justine. I'm going to direct this over to Mark. You have a hydrology and flood control background. I'm curious how the impacts of drought and flood and the need to plan for and respond to both simultaneously are impacting your work. And if possible, I'd love it for you to comment on the Pajaro River Flood Risk Management Project. Thanks, Mark.
Sure, yeah, thank you. Two main issues that we face come to mind in terms of the increasing whiplash on the drought and flood spectrum. One is communicating that risk to the public. So at the Pajaro Regional Flood Management Agency, we interface with the Emergency Operations Center in both Monterey and Santa Cruz counties, and we're providing some of the intel that goes into the decision-making process on when and where to, for example, evacuate people. And as we go through the process of communicating that risk, it's going to become even more important that new tools and technology are brought online so that we can refine and fine tune that communication. Because as we go through that whiplash and as we go through storm seasons like 2017 or an arc storm type environment, we're going to be faced with decision fatigue, but also fatigue from the community in terms of responding to the requests and requirements that we send out to them in terms of, for example, evacuation. So we're going to need to fine tune that. The other component that we deal with in terms of, I think what we're looking forward, not looking forward to seeing, but what we're going to see with this whiplash is a real change in maintenance requirements. We're already starting to see in some of our river channels, such as Pajaro and elsewhere in Santa Cruz County, bars that have mid-channel bars that have vegetation growth on them. And as many of you know out in the audience, vegetation growth is one of the things that you usually have to control in terms of conveying floods through channels. And as you go through less frequent but more intense storm systems, those intervening years and longer term intervening years of dry years are allowing that vegetation to grow thicker, taller, and that's putting increasing pressure on our maintenance environment. And what I think we're also going to see is a lot more sediment in our channels from fires. The whole drought component to the whiplash, we're already starting to see a lot of intensity in the frequency and magnitude of wildfires. That has direct impact on our flood operations and channel systems because they tend to deliver a lot of sediment when we go back into that other phase of the whiplash, when we have the large storms and a lot of sediment delivery. So that's going to be a real challenge for us.
Thanks, Mark. Ivan, I know today we're focused on a lot of water related climate change impacts, but of course, there are many additional impacts to climate change that can significantly impact communities. Drawing in your experience as a tribal historic preservation officer, what would you say some of those factors are, and how can we ensure they're considered?
That's a really good question, because not only when you consider communities in their response to climate extremes, floods, droughts, fires, and the lack of capacity or the need for building communication, you also have to consider in what is important to that community. As a representative of Buena Vista Rancheria, not only do I have to consider the tribal members, the surrounding communities in Amador, Sacramento, and San Joaquin counties, I have to consider what are sacred sites, what are tribal cultural resources, what are resources for the entire community, whether that's housing, whether that's drinking water, and how these all are affected by the climate extremes. Recently, during one of those AR events, we had a sacred site wash out on a hillside for the tribe. And I have to deal not only with the protection, preservation, and the restoration of that site, I also have to contend with the elders who have to walk up that hill, who would walk up those staircases and try and get and practice their cultural beliefs. So not only is there a lack of capacity and a capacity building, there's also a great opportunity for us to start building these connections, building relationships, to co-manage, whether it's the resources in the river, whether it's willow stands, whether or not it is collective open public spaces. An open relationship needs to be started at the beginning because now we have climate scientists. I'm an archaeologist and an anthropologist by trade, so it's nice to see the climate science coming together and be able to forecast things. But now that we can forecast them, we have all of these beneficial uses and all of these new ways of knowing things. We have to bring it in and start building the infrastructure to address these things.
Thanks for that answer, Ivan. We're going to transition a little bit of this conversation. We've covered how communities are dealing with this whiplash between drought and flood, but I really want to dive in deeper into risk communications. Mark, you've alluded to that a little bit, as has Ivan. This question is directed to Mayor Leon. I'm hoping he's online. Mayor Leon, we know that underserved and vulnerable communities typically bear a disproportionate share of adverse impacts of extreme events, but communicating clearly about those risks can be a challenge. In your experience as the mayor of the city of Huron, and it being relatively small with around 600 or 6,000 full-time residents, but that population more than doubles during harvest season, I'm wondering if you could talk to us a little bit how you communicate with your community about risk.
First of all that data has changed since since the drought began and since the last census. We're at 7,600, and the lettuce season used to bring in 8,000 people per season, twice a year, early spring, late fall. Now it's in the hundreds due to the drought. The way that we communicate emergencies is we have a phone system called the Blackboard that contacts every single resident in the community to notify them in English and Spanish. We also have a marquee outside of town. But honestly, I would like to see a better system. I've been advocating so that we could have a better emergency preparedness, or disaster preparedness and emergency system, and that continues to be one of my goals. So it's a small town, but the politics are still the politics. What I think the more important fact is prevention. We used to have a flooding that would take out the state route in front of us, and it was very dangerous for residents. Some residents got caught up in that stream where the creek goes through the road many times. One time, and well, every time this happened, everybody knew that you had to go around. You couldn't go in through the north side of Huron. One year in '95, there's some emergencies that you just don't know, and to be able to prevent, other than the need or the having of the infrastructure that's needed, right? So every time it would flood on 269, people knew they had to go around. In 1995, 6 of our residents who worked at Harris Ranch, if any of you drive down the 5 past those stinky cows in that area, they knew they couldn't go through Huron through the north side, so they took the alternate route. The most logical alternate route was taking the 5. What they didn't know is that the storm had taken out the bridge on I-5, Arroyo Pasajero Creek Bridge, and so 6 of our residents died. The last body was found out there near our State Route 269, where a memorial still sits today. Fortunately, and fighting early on in 2005, we were able to get 13 million. When I became mayor, I got the other 18 million. Now we got a bridge. If there's a huge storm, I think it'll weather that storm. But everybody's anxious. People think that the storm is scared of 269 bridge, but emergency, sometimes it'll be too late. If it's a flash flood, I mean, it's probably announced on the news and so forth. But I don't think there's a system that at least my city has currently to be able to take that into account and have a good emergency response to it in regards to a flood. When it floods in town, it floods out a few stores, and that's also due to the lack of infrastructure. Environmental justice and low-income communities have gone with many decades of the lack of investments for infrastructure. And I think that's where the focus should be. We speak about equity often, but I think we'll really know equity is happening when that infrastructure is being upgraded, and communities like Huron that houses thousands of hardworking farm worker families, giving them the quality of life they deserve, so that they're not afraid of a storm coming through and flooding out their homes. So I'll leave it at that for now.
Leon. Yeah, I think you've called out some really important themes that we want to keep diving into. Mark, I'm going to turn to you next. I'd like your perspective on risk communications as well. In Santa Cruz, climate change is creating impacts that weren't necessarily visible before, namely related to sea level rise. How are you communicating locally about this very real risk? And until just recently was maybe a little more theoretical in your area.
Yeah, we've been seeing a lot of changes at the coast on the Pajaro River. All right. Sorry about that. Yeah, so we have been seeing the effects of sea level rise. What has, and I think this showed up in Dr. Ralph's slides, that what was in the not too recent past a very kind of theoretical consideration, what we're starting to see are the real effects of climate change playing out. We're seeing agricultural areas in the lowermost Pajaro River that are seeing increasing seawater incursions from high tidal cycles that are superimposed, of course, on top of regional sea level. And that regional sea level, of course, keeps rising. And so the tolerance for agricultural productivity in the lower part of our watershed, as well as the flood pressures that go along with that, are increasing. We do have a really fantastic partnership with both the federal and the state government to rebuild levee systems along the Pajaro River. And that partnership is with the Department of Water Resources and with the Army Corps of Engineers. And implicitly built into that design is addressing the climate change aspects coming from rainfall patterns as opposed to just sea level rise. So we're trying to address the sea level rise issues through some separate projects in the lower part of our watershed, and then not too far inland, moving up through the leveed portion of Pajaro River, we have a very large levee reconstruction project and setback project that's going to come online within the next decade. And so we're looking forward to that, and we're thankful for that partnership.
Thanks, Mark. I'm glad you could give us some real-time examples of some infrastructure projects that are going in to work on this challenge. Justine, recognizing that risk communications need to be localized, how can we improve communications for emergency response and longer-term planning?
Well, first I would say we want to pay attention to what message we're delivering. If the message is just, look out, this is going to be terrifying, that only goes so far, right? Especially when you're speaking to communities that don't have extra resources to just kind of improvise and get ready, then, however it seems best in the moment. So the advice should be pointed. And that said, that means a lot of thinking ahead on behalf of state agencies in coordination with communities, right? It should be a conversation. What sorts of things happen when it rains a lot, right? Maybe for some people that means that the roads in their area flood and they can't get through. For others, the issue could be that they don't know where to evacuate to if that's necessary. There might not be a community center nearby, right? That's always accessible. And so those who are trying to prepare these kinds of communications need to keep in mind that climate change is a threat multiplier, and really try to cover the bases, right? Maybe the hardest thing about all of this is that we can't just look back on our past experiences. And so it means trying to identify the minutia of problems that can appear outside of our normal experience. For example, in the community of East Arosi, they recently had a water outage due to aging infrastructure coupled with the pressures of low water levels. And during the period of time when they didn't have access to water, a fire broke out in a home. There wasn't water for the firefighters to use, and that information wasn't communicated to them. And so they showed up with a truck with no water, and then there was such a delay that the house was lost. Luckily, there was no loss of life in that circumstance, but you can see how the situation just gets more and more out of control. A similar, maybe difficult dynamic to identify ahead of time is that a lot of homes in the Central Valley, for example, use swamp coolers for their cooling. So if you don't have water, then you can't cool yourself in the extreme heat. So again, this idea of threat multiplying. And then I think just one other really logistical thing is the communication system really needs to be improved. When East Arosi lost water, and that happened just this summer, there wasn't really a directory to contact people and let them know where they could get bottled water during that period. And so there was a reliance on nonprofit organizations. Of course, we're happy to fill that role, but we're not in every single community, right? So we need some kind of strategy to accumulate that information, make sure we're in contact with people, perhaps similar to what the state was able to do when it sent out text alerts to everyone to reduce energy use, right, during the extreme heat wave. That could be really life-saving in these situations.
Thanks, Justine. I appreciate this panel calling out kind of two different timelines. There's a communication system need for emergency response, but then also a communication system need for some of the information that Dr. Swain and Dr. Mark presented to us, this transition from what academics and researchers are sharing with us. How does that get to the community? So Ivan, I'd love for you to add to this conversation. How can we improve these risk communications to ensure that our messages are reaching broadly into these smaller and more vulnerable communities?
So one of the approaches Buena Vista has started to take is with DWR, multiple state agencies, and even the federal government is I go out and I start establishing relationships ahead of time. Before an oil spill happens, before a fire occurs, before a flood happens, I have already established relationships with those agencies. Agencies have tribal liaisons. They have community relationships people. They have huge departments. Buena Vista has me and my 2-person team. We go out, we give them our personal cell phone numbers. We connect with them. We communicate with them. We establish pre-communications. And that's all part of this communication. If I have an issue, whether it's with cultural resources or there's a fire burning up the hill, or there's a drought coming and I'm worried about water management, those people already have my phone number and they can call me. They have my email address. They know where I work. And so most of them, especially the ones I work closely with, know where I live. They can come to my house. They can establish communications that way. And that's a key infrastructure point for vulnerable communities, not only indigenous, but farm workers, disadvantaged communities throughout the state of California. Is if you can establish and create these relationships with locals, you can start staging, you can start building capacity, you can start even funding and doing collective co-managements to get ahead of these curves, whether it's sandbars that Mark is dealing with overgrowing, if you're dealing with delta issues like Buena Vista is, or you're dealing with fire issues, you can always have a phone call, have a meeting, shoot a quick email, say, hey, this is who I am. This is who I reach out to. This is how we kind of go forward together. Because we all live, all 40 million of us in California plus live together in this very bountiful and beautiful state that has been tended and cared for thousands of years. Let's actually have relationships between North and South, hills and Delta and coast. And these are the kind of relationships that will see us through all of these climate extremes.
Thanks for that response, Ivan. So we're going to transition to kind of the last question for our panelists today. And this is really, I've asked them to think of a call to action. What's really important when we come together like this is to think about, what would we want this big audience of policymakers, academics, NGOs, community members to really be thinking about. So Mary Leon, I'll start with you. What would you want all the folks in this room today and the folks online what's their call to action?
Just to, a lot of our communities in the Valley, in California, farmer communities, low-income communities have been underinvested for the past probably 100 years, we used to see more resources when we had more farmers living in the community. It's different now that it's mostly farm workers. And so I think we need to put it down. And if we're going to disproportionately impact, let's disproportionately impact with a disproportionate amount of resources for the infrastructure for communities so that they could be climate resilient. Through the communication system, just thinking about it, hearing the brother, the community, communicates with themselves really good, but I think social cohesion is a part of it as well. We're building a multimodal, culturally relevant pedestrian refuge, aka a plaza. I got the funding for it, and that's an infrastructure tool to empower social cohesion, bringing people together to be able to build those bonds, those relationships. Because during crisis, there's nothing more potent than people helping people. Just as it happened when the bodies were discovered or were recovered out in the creek. It wasn't anybody but the community itself, from the recently arrived farm worker, immigrant, to the third generation, non-Spanish speaking Latino that they all came together with buckets and shovels and recovered all the bodies. That type of solidarity is what we need to be able to get through what's coming. Climate resiliency is really, really about the people, uniting and having a common understanding. And so resources for communities like my own, to be able to have that campaign also in terms of water conservation, because we're doing as much as we can in terms of water recharge and the system to have more water available, because we know it's going to be hard times. And the way I see it is that if I don't create the infrastructure, the system right now to be able to, get through the hardest times, then it's going to be impossible. But I think just more attention to communities like my own, cities like my own, with resources, support, technical assistance, and so forth. I think that's where it's at. Come and visit Huron. We got the best tacos west of Mississippi. I'll give you a tour of what we're doing in terms of underground water recharge, the 3,000 acres that we're looking at for a nature conservancy. That would be a huge thing for underground water recharge, as well as carbon sequestration, because that's the way we got to be. And in the process, I think that we build out the green industry, the new careers. Thank you.
Thank you, Mary Leon, for that powerful message. Mark, over to you.
Yeah, thank you. I have two suggestions, and they're not new in any sense of the stretch of imagination, but think outside the box. And like the mayor said, reach out to your partners. And I'll give two examples. So one is in our county, we're served by a weather service radar that's just too high. It's up on the top of a peak and it shoots over a lot of the storm systems. And we've had real impacts with this on monitoring storm systems and the floods they create. And so we jumped on to the back end of a program that's called AQPI. That's in the Bay Area, where they're installing a bunch of equipment, including what are called X-band radars. So we applied for a grant with the state of California to purchase our own X-band radar to install essentially at sea level. And the grant provided some amount of support for that, but we still had a margin that we needed to come up with on our own. And we reached out to a bunch of local partners, including fire agencies, water agencies, and we just had a very small ask from them, just a small, $2,500. Can you contribute something towards this? The data is going to be shared, it's going to be publicly available, and it will help us. It will help you with your water supply operations. It will help you with your fire weather monitoring for smoke plumes. And we got a huge amount of support just from the agencies within our county. And it made all the difference in just narrowing that gap. The other thing we did in terms of partners, and I go back to our larger levee reconstruction project, is we were facing really acute challenges in terms of funding the project. It's a $400 million project. We have a cost share on the federal side coming from the Army Corps, but we had a not insignificant amount that we were going to have to come up with from our own local community, aside from partnership with the state. And so we put our best foot forward in terms of securing as much revenue as we could from the local community, but we were still short. It was a very important project to us. Turns out to be a very important project to the state of California as well. And we made the extra effort to demonstrate that we did all of our due diligence, and we asked. And the worst thing you can get out of asking is a no. But we fortunately got a yes because we did our best effort. And so that is what has resulted in us able to move forward on a project that's literally been in the making for 60 years and hasn't been able to move into that design and construction phase. And now it is. So it's a huge, huge step forward for our community.
Thanks, Mark. Ivan, over to you.
I really have two key points to make. And the first one I want all the agencies, everybody online to consider is you have two timelines. You have the pre and the immediate part, and you have the long-term section. Whether those capacities need to be built immediately or ahead of an event, start establishing those now, but also continue those relationships into your long-term, into those 40 or 50-year plans. We keep getting these timetables of this is going to happen in 10 years. This will happen in 200 years. Remember that relationships you establish today will greatly help you in the moment of crisis. Those kinds of timelines both need to work coherently. The relationships, the consultations, the ideas presented, and the small, minute problems that were mentioned by my panelists can get addressed immediately and can prevent further hiccups down the line. The second point is turn consultation on its head. I say consultation because I'm a TIPO, I'm a cultural resources advocate, I'm a protector, and that's generally government to government. But if agencies, cities, counties have plans and ideas, bring in local stakeholders, not just tribes, bring in undervalued, underrepresented, low economic depressed communities, bring them to the table at the beginning, at the drafting table. There are local ideas, local knowledge, traditional knowledge, indigenous knowledge that can make your project succeed and stop the roadblocks I have to throw up further down the road. Don't bring us in at the last moment where we may be opposed because of some other issue, some other political stance, some other cultural stance. Bring us in at the beginning. We want to see California thrive. Agencies are not going anywhere. Police departments aren't going anywhere. The county and the state aren't going anywhere. Neither are the tribes or these communities. So let's build a cohabitation relationship and work together so that we can actually get through all of these extremes that we have seen today.
Thanks, Ivan. And Justine, we'll close out with you.
Great. Well, my fellow panelists brought up really wonderful points. The importance of multi-benefit projects, ensuring that, we're, let's see, what is it? Feeding two birds with one scone. I like that saying. And gathering more information, better monitoring, working together towards that, and incorporating local knowledge. I do want to point out that the 1861 flood that was mentioned, the native peoples of California knew that that was going to happen. That's documented, and they left. They tried to tell people and they were laughed off. So yes, local knowledge is really critical. And to build on this idea of multi-benefit solutions, green and gray infrastructure, to ensure that we reach the most vulnerable populations, you really have to get specific. Sometimes in talks around SGMA, right, sustainable groundwater management, which has its place in climate resiliency, certainly, in fact, came about because of increased drought. Sometimes conversations start to turn around like, well, there will be a general benefit to the basin if we put more water in the ground. And while that's true to some extent, if the water goes in right where it's being pumped out, the communities never see that benefit, right? So if we want to really uphold the human right to water, which the state of California says we do by law, then we have to look at what that really takes. That means maintaining levels that shallow wells can reach. That means maintaining water quality, which, as we touched on, gets more and more complicated, including during floods. Yeah, so we have to be real about the scale that we have to look at things. I think that's the, if I could make one more point, actually. Funding really needs to be directed towards those specific endeavors. And I would say there needs to be more discussion around how we can equitably ensure that farm workers in particular and essential workers are also compensated when extremes make farming difficult or impossible, right? Like already farm workers need to be sent home if temperatures reach extremes. That makes total sense, but they don't actually get compensated for it. Whereas the owners of industrial farms, for the most part, have like insurance to cover those kinds of events. We can't let the basic building blocks of our society, of our economy, fall away as we deal with these challenges. And I want to credit my colleague from law school, Ana Orozco, who comes from a farm working family and has done a lot of thinking around that and bringing that to my attention. So thank you all.
Thank you, Justine. I'm going to say a few closing thoughts. I've really enjoyed hearing from this panel today. I hope all of you have too. Something that comes to mind is, the director had mentioned this morning this concept of partnership, and I think this has come up through many of the responses you heard from this panel today. And something that I think is really important is to think about kind of the sequence of that partnership. And I've heard from a couple of our panelists, there's different timelines we need to consider, but also different venues, because when we think of access, it's not just about access to information, but it's also access to decision making. And so for community members, that is critical. What I've heard from these folks today is it's not just about the aftermath of how we inform folks an emergency is coming. It's every step of the way engaging community members in the decision-making process. And so I think as a call to action to you all is keep that in the back of your mind today as you're learning new information, you're making connections with each other. Look around and see who's not here. And what are you doing proactively to make sure that you're engaging them in this process going forward? Because we know a lot of these communities that the folks on this panel represent and serve will be the individuals that are most impacted by climate change extremes and the natural disasters that we've talked about this morning. So with that, I thank all of you for listening to us. Let's give them a round of applause. Back to you, Mike.
There we go. Hi, everybody. All right. So what we're going to do is we're going to take a quick 5-minute break. We'll get panel 2 up here and situated. And in 5 minutes, we will be live as I will transition from MC to moderator. Thank you. background on a project that started in the 2012 to 2016 drought as an exploration to see what was possible. And this is really cool. There I am. Let's see if we can keep going. Next slide. There we go. All right. So on the theme of the day, what I really like about the slide are all the little icons on the bottom talking about collaboration. A lot of people working together, and this has been such a fantastic space that we started with FARO. So a flexible water management strategy, flexibility. And it's great because it takes knowing the state of the watershed and knowing what's coming through a forecast, using that knowledge to help manage the water in the facility to greater benefit. And not only in terms of water supply benefit, but in terms of flood management benefit as well. And it was one of the things that we started, and it was to see what we could do. And started in the Russian River and then expanded down to Prado Dam on the Santa Ana River with Orange County. And as with each project, you learn new nuances of the local condition, which is really fabulous, but then finding it still works, even better. That was really cool. Well, then we up to the complexity and we said, what about two, right? You can do one facility, that's one thing, but now you start saying, what about two? But we had a little bit of a help here. We already had two facilities working together for about a decade in Yuba Water and State Water Project with Oroville and New Bullards Bar Reservoir, working to coordinate operations to manage water for a downstream flood management point at Marysville. Now it's just folding in the concepts of FARO within that existing partnership. And what we found looks like it's going to work really well. I'm really excited. So this panel is going to kind of explore both what we've learned and kind of some thoughts about where we might be going, because we have some really interesting recent developments. So now I'm going to exit here. I'm going to reappear as moderator and we'll get started. All right, so as moderator, I get to introduce my panel. At the far end of the desk there is Dr. Michael Dettinger, longtime collaborator. In fact, when I became a state climatologist, one of the people I was introduced to was Mike, and have spent the intervening years really getting to learn about California's hydroclimate and the changes that we might see. Mike has been working with observations and climate and collaborations throughout his career, both in the USGS and now working with the Center for Western Weather and Water Extremes, as well as colleagues up at Desert Research Institute. Joe Forbes had good fortune. Joe started my interactions with Joe as he became the new water manager for the Sacramento District in 2017. Talk about your first water year on the job. Good news, that excited him about the possibilities. And as we got to know FARO and Joe really got to grow with the program. And it's really exciting to see. He started with us at Lake Mendocino, continued with Prado and Yuba Feather. And now, less than a month into it, is the Corps of Engineers Forecast Informed Reservoir Operations Coordinator. Is that a reasonable title there, Joe?
Good enough.
Yeah. All right.
I'll go with it.
Fantastic. Anyway, this is a fantastic development that we'll get to in the course of the panel. Next up, we have John James, Yuba Water Director of Resource Planning. All right, there's, hopefully got that right. So worked with John as we work in the Yuba Feather. He's also worked with their hydroelectric operations. I spent 14 years with Pacific Gas and Electric. And best part about this, here's a water manager who has an atmospheric science degree. So we have that crossover point between weather and water. And those opportunities are really key when you're trying to build bridges. So we're really excited about that. And now we have Adam Hutchinson from Orange County Water District. Adam's been doing this for a while, over 30 years in the business. 20 years in the district, worked as Director of Recharge Operations and Senior Hydrogeologist. So there you notice we've now added another facet of connecting surface and groundwater. And Orange County has been doing that for a long time. Also, professional geologist and certified hydrogeologist with the state of California. So now I get to switch over to my questions as we move the panel along here. We're going to start with Mike there on the end. Somehow things got a little out of sorts. My apologies. There we are. All right, start with Mike down on the end, and then we'll kind of cycle through our other three panelists. Mike, how do you feel the characterization of atmospheric rivers has helped frame this perspective of wet extremes and the broader background of drought?
Okay, hi. Hi, everybody. Thanks for being here. So in terms of, well, one of the biggest challenges that scientists have these days, earth scientists have these days, is what we tend to call R2O, which is research to operations. It's really doing research, doing science, making observations that actually find their way into actual applications and actual operations. And atmospheric rivers have been just the most remarkable gift in those terms. We heard a lot earlier from Marty and Daniel about ARs, and I'd just like to, just a few things, call them out, you know. So we've, in California, about 80%, actually over 80% of our major floods are associated with, are driven by atmospheric rivers. Something on the order up here in the northern 2/3 of the state, something like half plus or minus a bit of our droughts end with the arrival of some atmospheric rivers, generally a couple of them in a quick succession or that sort of thing. And I think Marty mentioned, you know, that we're really looking at somewhere on the order of 40 to 50% of our precipitation falls from these atmospheric rivers that only arrive in a relatively few number of days per year. And so they're important, okay? There's another thing, I want to read you something that I gleaned from a review of a preliminary viability assessment report for the Yuba Feather this summer. And well, let me just read it. Out of all the strong ARs that arrive in the Yuba Feather basins, 86% are correctly forecasted at a 3-day lead time. 80% are correctly forecasted to arrive at a 5-day lead time, and over half, better than even odds of getting it right at a 7-day lead time. So in addition to being really important, these atmospheric rivers are actually, our science about them is useful. We kind of know what to look for now, and we can use that. That kind of forecastability is frankly kind of astonishing to somebody like me who's been around for 40 years. It was not that way until very recently. And so I think that, you know, the trick with getting research to operations, as in my experience, long experience, is you actually have to have something that's important. You can't just necessarily be little adjustments to an already good situation or even an already bad situation. And it's got to be useful. And those may seem the same, but they're, by God, we could have something as important as ARs that we just didn't have a clue what was going to happen. So you need both. And it's not a question of convincing the stakeholders, the users, that it's both. It's got to be that way. And for us in California, this is a real gift. Atmospheric rivers really are both important, and what we'll see in this panel is just how useful they can be.
There we go. Thanks, Mike. Adam, you want to, we'll kind of work our way from you down to Joe, talking about this knowledge of atmospheric rivers and what are the management possibilities?
Management possibilities. Just go and do a different question now. Go for it. Okay, great. Yeah, I think the beauty of atmospheric rivers is it's very easily understandable. So working for a public agency where stormwater is an important source of supply for us, it's very easy for our board members and other people, our consumers, to get behind it and support it because it's a great visual. Atmospheric rivers. It really denotes what's happening in the atmosphere, even though the physics of it are very complex, and we're doing a better job understanding what they're all about. Getting that emotional support and that support of our policymakers has been really important for us to continue on with Bureau of Prado Dam. And so that's been really a gift, like you said, Mike, in terms of not only is it useful, but it's easily understandable from a layman perspective.
Yeah, I would just echo the same thing. I think, Marty and CW3 have done a really good job at, communicating the broad spectrum and types of ARs, when they're going to occur, when they're not going to occur, how strong they're going to be, and really, making those connections in terms of the impact and the precipitation and extension, into water management. So I would just echo, Adam, kind of your sentiments as well.
And lastly, I'll add that, so the Corps of Engineers, by design and hopefully appreciated by others, is a risk-averse agency. And so the importance of like identifying and naming and those of the Corps, like myself, understanding what atmospheric rivers are helps us then figure out what our next steps should be. We can identify future projects to pursue. We can then perform with our partners analyses to show like, well, then now that we know more about what atmospheric rivers can do, then how does that translate to a response at reservoir operations decision-making? And so just the fact that the terminology is not just understood with our partner agencies, but also better understood with the public as well. The actions that we take and the communication around those actions are just they're just done better now. And so and it's just a result of all the hard work that's been done in better understanding and forecasting atmospheric river phenomena.
All right, fantastic. Well, we'll move on to question 2. And Joe, we'll start with you. Talking about new perspectives that you've gained from our 3 pilot projects.
Yeah, so quite a bit, actually. In fact, I'll even reference an example that I'll term pre-FURO with the Folsom Dam and Lake with the new spillway and the water control manual update there, is that we found through that and then through these FURO efforts that FURO isn't just potentially useful for one thing, like not just for flood control or not just for water supply, but we've found that in these various pilot projects that you can see potential benefits in a multitude of areas, and which is important because a lot of these projects have multiple authorized purposes for which they're supposed to operate to. So that was a kind of a revelation that we first saw through working with the Folsom update to the reservoir operations, and that we've seen time and again with these other pilot projects as well. And specific to the Corps, one thing that has been shown to us is how much diligence it takes to try something new and overcome any sort of procedural or regulatory inertia. Because there can be, and it kind of goes to the research into operations thing that Mike was talking about, that you can have a good technical or scientific idea, but how can you get that into implementation? And there may be some obstacles that aren't the scientific obstacles, but just like procedural obstacles that you need to navigate. And so finding out what those are and navigating those successfully has been another aspect that we're continually trying to pursue and find out. And another thing that helps with this navigation is how can you characterize or put into context these new and novel ideas in the traditional ways that we've done things and that we're familiar with. We found, especially with a certain internal like offices or folks within the Corps of Engineers, but also partners, that if you can describe the newer things that we've been looking at with FIRO or pursuing in the context of how similar it is or where it's different from what we've already been doing, then that resonates with people more. Like I said, we're a risk-averse agency, and so if you present FIRO as in everything's new, we've never done any of this before, let's start doing it tomorrow, there's some hesitation with that approach. So I think putting it in the context of we're starting off with something that's tried and true, and people are familiar and water managers have been using forecasts for a long time. How can we go about doing that better? And so this starting with the foundation that we already have and just going a little further with stuff that's a bit that we've shown to be helpful, I think is really valuable. And the last thing that I think might go into a future question, so I'll just say it briefly, is that how important it is to have good collaborative relationships with partners on these sorts of projects that we're looking at, stuff that's new. All these partners are bringing to the table their different objectives, either personal or for their agency, that aren't necessarily in alignment with the other people at the table. But if you have good working relationships where pride isn't a factor and you're just trying to find out what the best answer is, you can accomplish quite a bit. And I think FIRO has shown that.
All right, Adam.
Yeah, thank you, Joe. Yeah, I think FIRO is, my exposure to it has really showed that this is a very unique, kind of almost like a unicorn moment where you have a unique win-win type of project where this is really what I would call a silo buster, which really something in it for everybody. I mean, even look at the people in this room and on this panel, it's really something in it for everybody, from water supply to flood protection to the environment. And so what we've seen is we've had close relationships in our watershed, but it's brought us even closer and really tightened our collaboration. And so I think it's really got broad support from everybody from top to bottom. So it's really a unique opportunity we have in California to really break down those silos and truly integrate water, and using ARs and FIRO as a kind of a genesis that hopefully will spread to other areas.
John, did you want to talk a little bit about this effort that we're building off of kind of a pre-existing collaboration?
Yeah, sure. So thanks, Mike and Adam and Joe. I think, really that's it, is leveraging this existing partnership and collaboration that we've started through the Yuba Feather FCO program. And that program, for those unfamiliar, started back in 2005. It was really a response to the 1997 flood event. And, really what it came down to is we needed a common platform to have discussions about how to manage for downstream flood control between, multiple state, local, and federal agencies, but also, the two reservoirs and the operational piece. And so, that program has continued to build over the years. And the benefit to our FIRO program is that a lot of the same organizations and people themselves are part of our Yuba Feather FIRO program. So that's been a real benefit.
And then kind of closing off this topic, Mike, just that aspect of FIRO and science informing application.
Okay, yeah, this is gonna seem a little fuzzy, I suppose, but I'll just, it's sort of is very much along the lines of what Joe was saying, but I'll just say it my own way, and that is that that probably the biggest thing I've learned from being involved in the FIRO pilot projects is that trust is possible, something like that. I got to tell you, we started this game back in 2013. I believe it was 2013, in the midst of a drought, and having just watched a lot of water released because of the rule curves, and everyone was a little bit frustrated about that because the storms stopped at just about the same time as we let the water out. And it was not a foregone conclusion that we were going to make any real progress on this. Some of our first meetings, there were people who would stand up and start to the door and saying, this isn't a conversation we can productively have. And it took, an amazing amount of diplomacy, which any of you who know me know that I contributed zero to that. But an amazing amount of diplomacy and tact. And frankly, all of us actually wanted this to work at some level. to get people to sit at the table long enough for this to happen. And that's a really difficult thing. And, you know, I'm a scientist and I should be probably yapping about what it takes to get research, more about what it takes to get research into operations. But really, the collaborations of, oh, it's no longer up there, but the list, the icons that were at the bottom of the logos that were at the bottom of the first slide up there. That is absolutely necessary for something like this to work, to make the connections, to make the possibilities happen. And it takes a remarkable amount of effort to get everyone on the same page and to all acknowledge that we're actually pulling in the same direction. We just have different constraints and different problems to deal with.
All right, thank you, Mike. So now I want to kind of loop it all, complete the circle here and start with Adam and talk about how, you mentioned you were a tight knit group to start. How did that help FIRO? Because here's this new idea you're bringing to the table. And it helps to have existing collaborations that can help that effort move forward.
Yeah, so a little bit of background at Prado. We've been doing stormwater capture at Prado Dam since the 90s for a long time. And so we've had a long standing relationship with the Corps of Engineers and great collaborative working relationship. But FIRO has really intensified that effort and really brought us even closer together in terms of finding the win for both of us here. So, and it's also brought us together with the environmental community. We have a lot of environmental resources we need to be aware of behind Prado Dam. So we're working very closely with them. And I can't say enough about the Corps in terms of their willingness to partner with us and work with us and really push the envelope in this. And I'll have to say, I'm amazed at how high up in the organization the support for FIRO has risen. It's gone all the way up to headquarters level and back in the Pentagon. And they're throwing money at it. They're really behind it and supportive of it at the highest levels. And I attribute that to people like Joe and Marty and others that have really shown that the science is practical and useful for everybody, including the Corps. And so can't say enough about the collaboration. Like I said earlier, in my earlier comment, this has really brought us together, the water community, in pretty dramatic ways. And I think we'll continue to do so.
John?
Yeah, so just to add on, I think it's obvious that collaboration is key in the FIRO process. And for UPA FIRO, you can kind of think of it as 3 projects in one. You have Oroville, you have New Bullards Bar, and then you have Oroville and New Bullards Bar combined together. And really good partnerships are built through that communication and having that trust. And I think one of the benefits through the FCO, the previous partnership through the FCO program, is that we're really looking at ways to have a smooth transition from research and development into operationalizing FIRO. And I think that's going to be really important as we try and to translate these R&D type activities into operations.
All right, that actually makes a nice segue into our next kind of part of this panel, which is really looking ahead. We've achieved some really exciting things, and now we want to start thinking about what could be next. And we'll start with Joe here with in the area of adaptation as new technologies become available. How can FIRO evolve and adapt to incorporate those?
Yeah, that's a good question. And just a little bit of background for everyone. So historically, the Corps of Engineers doesn't get funded regularly to update the rules that reservoirs are supposed to follow for meeting their authorized purposes, at least for the ones that the Corps is involved in. That's usually something that doesn't get funded as regularly as we and the water management offices of the districts would like to see, but the decisions are made for good reasons. And so a lot of these rules that currently exist were developed decades ago. And as we've already seen with the keynotes this morning, it was a lot of these decisions and the rules that were written were based off of information about the climate and the watershed that is no longer as applicable as it once was. So the challenge for us at the Corps of Engineers is how can we, when we have the opportunity like we do now with where we have funding to update water control manuals and we have funding to engage in FIRO projects, how can we make the best of that opportunity? And so one thing that we're exploring, and Marty mentioned it briefly in his keynote, is this idea that we've just given the term FIRO 2.0, was essentially is, can you like do analysis now and prepare now, so then that way when forecast information is even more reliable than it is, can you safely start using that information without having to start a potentially convoluted Corps of Engineers process all over again. And so we're exploring that now, and we don't know what the complete answer is yet. I think realistically, we won't be able to forego updating water control manuals forever. There's going to be instances where you're still going to have to start a new water control manual update at some point. But how much can we just make the use of the time that we have, where we've got the team built and the momentum going, to where we're making it easier on us, we're making it easier on our future selves. And so that's what we're trying to do with these pilot projects and these other more programmatic FIRO efforts, is how can we do as much now to benefit us later?
Fantastic. John, do you want to talk a little bit about new technologies that we're seeing even in the FIRO project you're working on, things like ASO that add more information?
Yeah, sure. So I think, some of these items like ASO that are very complementary in terms of, understanding the spatial extent of the snowpack, the state of the snowpack, that play right into, the understanding of the concept, which we're developing right now, which is this FIRO space. So this area of operational flexibility within the reservoir that historically has been, denoted with rule curves. And so I think, programs like ASO and other forecast improvement initiatives just sort of complement and feed into that process of better understanding and positioning yourself as a reservoir operator for, both the extremes and just normal operations.
All right, now I get to catch myself for using inside baseball. For those of you that aren't familiar with ASO, this is a research project started with NASA's Jet Propulsion Laboratory to look at new ways to measure the snowpack in the Sierra Nevada. And ASO stands for Airborne Snow Observatory, which has now pivoted to a company that collects that data and making use of that data to better understand the state of the snowpack within the watershed, which helps then provide information that feeds into the forecast and ultimately the water decisions made. Adam, before we leave this question, let's get over to you to talk about kind of Southern California's unique.
Yeah, you're talking about how resilience now? Yeah, great. So in terms of Southern California and our experience at FIRO, FIRO is increasing our groundwater resilience in Orange County. On an average year, we capture and recharge enough stormwater for 200,000 people already with our existing program. For every gallon of stormwater we capture, that's the offset directly of imported water that we need to take from the Colorado River in Northern California. And as you know, those imported waters are facing a lot of stress right now. So every acre foot of stormwater we capture, we're much better off. And what's interesting too is FIRO will save us a lot of money. The cost to capture and recharge stormwater is about $20 an acre foot. The cost of imported water is 40 times greater. So a tremendous cost saving. Interestingly enough, the energy footprint of imported water is 40 times greater than the cost of recharging stormwater. And the quality of stormwater is much greater than the Colorado River, as you know, pretty salty water. So we benefit on multiple fronts with every gallon of stormwater we can capture. So it's making us more resilient and saving us a lot of money and making the water quality better. So we win on every front on that aspect.
Fantastic. Like to hear that. All right, well, let's actually talk a little bit about building on that, of going from this idea of FIRO as a facility-based perspective and building that concept more to where we're going to head, and we'll explore more actually in our next panel, but building that out to the watershed. And so how can FIRO connect with other aspects of watershed adaptation that facilitates more resilient water management? It kind of builds on this, so you start connecting pieces together. And John, we'll start with you.
Sure. Thanks, Mike. I think, FIRO is really, one important tool in the toolbox, but, it is just one tool. Always think about, what are the other complementary programs and initiatives that can go along with it. And I think I'll talk about a few, today. And I think, one of the challenges in our watershed and Sierras is, extreme wildfire. We've seen wildfires, in the Feather watershed these past couple of years. We've seen the fire down in the American watershed just this past year. And so, forest health initiatives to improve the conditions of the headwaters, I think, are another key that could be complementary to FIRO. The other thing is, improving other forecasts, understanding seasonal and subseasonal forecasts. I think we touched on it just a little bit before, but understanding the state of the snowpack and the variabilities that can influence runoff into the reservoirs are going to be key. And that, connects to some of these places that have experienced wildfire, and what is the changes to hydrology and things like that have gone along the way with those. Again, wildfire can have changes in runoff patterns, debris flow, water quality issues. So there's a lot of things to consider there. Another element that I did want to bring up was, this thought of, enhancing our existing infrastructure to be more resilient and work with FIRO. And I think, many of you know that UBA is working on a project, a lower outlet at our facility called the Atmospheric River Control Spillway. And really what this is a project to complement FIRO releases ahead of large atmospheric river events. And it would give us the ability to manage an additional 100,000 acre feet of water for flood risk reduction benefits. So again, these type of ideas of complementary programs and potentially, infrastructure projects, I think are key when we think about, the benefits of FIRO going forward.
Mike, any thoughts on this idea of the watershed as part of FIRO?
Say, we're in a time of climate change, and it's a accelerating climate change, and it is going to change our watersheds in ways that are going to change our inflows to the various reservoirs and the like. And so in addition to the sorts of things that John was talking about of forest health and the like as alternatives or as complements to FIRO, for instance, we really do need to be thinking about the entire watersheds to really understand what the challenges that FIRO is going to face for the next generation. Not sure if that's a very helpful comment, but I do think that the headwaters are an issue that needs a lot more attention, and I'll just say it since I'm sitting here in DWR. DWR really kind of needs to find its way to working with the other state agencies to better attend to what the headwaters mean for most of DWR's problems in a time when those headwaters themselves are going to be changing.
All right. Collaboration as an opportunity. Anyway, let's move over to Joe real quick. Joe, kind of talking about the aspects of watersheds, but also understanding the relationship that the facility has based on the reason it was put there in the first place.
Yeah, that's the one of the challenges is going to be back again to talk implementation, is that how can we work within the authorized purposes of a project to implement new and useful ideas. And if that's not possible at a location, what other steps are available to take? Does that require other core or other types of processes for new authorized purposes, or something that requires more collaboration than just between research to operations, but policymakers and decision makers? And there's going to be we expect there to be some instances when you're looking at, well, can FIRO work at this place, that you might have a good scientific answer, but maybe not a good implementation path for that. And so the always being aware of how to be flexible and adapt to not just the science, but also to the political or relationship landscape that there is going to be important. And I think it's important for people to know that, like, in the water management community, like, the use of forecasts isn't a new idea. It's something that they already do, but they could be limited to how much they can use that information based off of different policies or rules or laws. And so those might be some things that need to be addressed if you're looking to implement FERO at a specific location. And that might not be as readily available to accept it because of other obstacles or frameworks that are currently in place.
All right, that makes a fantastic way to get us to our final question on the panel here. And it's each of you provide maybe something to keep in mind with climate change and an adaptation strategy like FERO. What's something about climate change we want to keep our eye on? Just something we might be thinking about down the road. Maybe start with Mike.
Way to go. Okay. Okay. Let me see. Today we've heard a lot of fairly pointed projections of climate change in the keynote speakers, among the keynote speakers and the first panel. I was going to break a rule there. We were sort of admonished to be specific by somebody on the first panel. I don't remember who. Okay. But I'd like to generalize a moment and take it back a couple of steps. Some of the more important, some broad aspects of what climate change is going to be. I just want to call them out. It's going to be pervasive in the sense that we all over the state, and you can expand that as far as you want, but all over the state, we are all going to be scrambling, all the communities, all the agencies, we're all going to be scrambling to deal with this evolving world. Yes, so we're all going to be scrambling simultaneously, basically, more or less. But we're all going to be scrambling with completely different or very different heterogeneous versions of climate change. None of us are going, it's going to be you're going to be lucky if you find a community that's dealing with the same suite of problems that you are, in the same, magnitudes and that sort of thing. And it's going to be coming at us from lots of different directions. We tend to think about it in terms of warming and maybe precipitation, especially if you're a hydrologist. But it's going to be coming at us from multiple different directions. And at the same time, so that's a bunch of bad stuff. And that's really the good news, because the bad news is we're already in the midst of it. And it's highly uncertain what it's going to do and what it's going to look like. And that uncertainty isn't going to suddenly disappear 10 years from now or something like that. We are going to continue to be in the midst of it and continuing to be facing uncertainties about it. Now, it's a big, broad sermon there, but I'm on a FERO panel, and I just want to say, if you think about that world where we're all scrambling, we're all trying to deal with our own problems, our own versions of the problems, and the situation continues to be uncertain. I gotta say, FERO is a hell of an option to consider, and it's a tool among others out there, but it's a tool that is, in many cases, probably, I'm going to say by far most cases, that's my opinion, are going to be vastly cheaper than a lot of the structural responses. And the trick to actually making FERO be that way, a flexible and economical alternative to consider, is if we can make it actually flexible and actually economical. If we are locked into a process that takes a decade to revise and get to the changes that we might need in the future. By the time that decade's gone, we're going to be in a whole different world with a different set of uncertainties. And if we can't figure out how to make this truly flexible and adaptable and evolvable, we will have tossed away a real important option. FIRO is not going to work everywhere. It's not going to work everywhere, but it's something to be in most of this state. If you're dealing with with a reservoir, you probably want to at least give it a pretty thorough look, because it is a particularly cheap and a particularly flexible. It can be a particularly flexible approach to dealing with these climate pervasive, heterogeneous, multivariate, uncertain climate changes that are coming our way.
All right, Joe.
Yeah, to follow up on what Mike was saying, he's set the stage really well, because at the Corps of Engineers, as he's taught, what we need to be working on, and what we thankfully are working on now with our partners in the FIRO efforts, is to establish like the framework for, on the implementation side, how do you know how the forecast reliability is changing, hopefully in the positive direction. But if it, for whatever reason, ends up not being in the positive direction, we need to be able to understand and quantify that, so that way you know if you should be doing something different, that it's appropriate to do that different thing now. And so that's an aspect of that FIRO 2.0 idea that I brought up before, is being able to know what are we looking at? How do we know how it's changed? And now that we know it's changed, does it matter that it's changed? And if it does matter, now what do we do? So making sure we know what that path looks like is important, because Mike's right that if you wait until 10 years down the line, when you would normally complete a process like that, you've finished a product that now is 10 years out of date and you start all over again or something. So I think that's really important, at least for us on the core side. And the challenge also, again, with other water management offices in the Corps of Engineers, is that I think hopefully people see the potential benefit of FIRO, but there could be certain people or groups that would think that like FIRO is some sort of panacea and will solve all problems. And it's important for not just the Corps, but I guess our partners as well, to be prepared to provide an answer for if someone, if a decision maker or a funder or something asks, like, or tells you we should do FIRO here, you have the information to say like, yes, that's a good suggestion. Here's why we think it might work, or here's actually why we think it won't work right now, and actually have the reasons for why. Because we've shown it to be beneficial, but as Mike said, it won't be beneficial everywhere, at least immediately. And so we need to be prepared to have the information for why or why not it's being pursued. And so that's going to change as the climate changes too. So I think that's also very important.
All right, thank you, John.
Yeah, I'd just say, echoing kind of what Mike and Joe are saying, adaptability is going to be key. I think, testing out these FIRO applications and potential, future implementations is going to be key to see what works and what doesn't. It's not going to work everywhere, as we've been talking about, but there are a lot of places that will work. And while it's just, one tool in the toolbox, I think it's a very important one, especially as we progress going forward.
All right, Adam.
Yeah, I think I'll take a page out of Mike's book and talk in a broad sense. I think you've heard the word climate change adaptation. I think we're beyond adaptation. We need to evolve. We need to evolve with the changing climate. It affects way more than water. It has a ripple effect all the way through our culture, our society. So I just want to put the challenge out there that FIRO just represents one evolutionary step we're taking in the area of water, but it's going to affect every area. So just to be open-minded and evolve with the times, and be able to respond and adapt to what Mother Nature is providing.
All right, thank you, panelists. Give you all a hand. Appreciate your participation. All right, well, thank you for that. Now we've got another 5-minute break while we trade panels again. We've gone from what's now Next up will be what's next. 5 minutes, everybody.
Green?
Maybe, oh, there we go. All right, everybody, welcome back. Thank you. And now we get to the what's next. And to chair this panel, we have Chris Chanel, our Deputy Director of DWR's Integrated Water Management Program. Chris is responsible for advancing policies and programs that bring things together, multiple benefits, flood management, local water supply, and ecosystem restoration. He oversees Division of Regional Assistance, Division of Planning, and Division of Multi-Benefit Initiatives. Chris, the floor is yours.
Thank you, Dr. Anderson. Really pleased to be here this afternoon. It's a pleasure to be here with this particular panel, whom I'll introduce in a moment here. But just wanted to say something really briefly, reflecting a little bit on the panels that we've heard so far today. In a way, almost taking it out of the specifics of the weather context or the climate context, it seems like a pretty clear takeaway for me is that if it's worth doing, it's probably going to be difficult. And if it's difficult, it's going to take partnerships and innovation to actually get it done. Partnerships across all levels of government, into the nonprofit sector, academia, tribal government partnerships, and beyond that. And also, when I say innovation, certainly the willingness to take the latest climate science in this case and really turn that into policy, into decision-making, into operational management of our system. Taking it from the brain, if you will, to the ground. And so because of that, I'm really pleased to have this particular panel here today to really round out this symposium, this climate-driven symposium. And specifically, who I have here today, I'll start with John Kane. John Kane is currently the Senior Director of Conservation at River Partners. And in 2017, he was named Floodplain Manager of the Year by the Floodplain Management Association. Earlier in his career, he served as restoration ecologist at the Natural Heritage Institute and staff scientist at the Mono Lake Committee. We also have Jane Dolan. Jane Dolan is a fourth generation native of Butte County and served 8 terms on the Butte County Board of Supervisors. She has served on the Central Valley Flood Protection Board since 2011 and is currently the board president. She also serves as the executive director of the Sacramento River Conservation Area Forum. We also have Chris Elias this morning. Chris Elias is the executive director of the San Joaquin Area Flood Control Agency, or SJAFCA. Under his direction and leadership of the board of directors, SJAFCA carries out its mission to study, plan, and implement flood protection projects, reducing the risk to people and the economy in that particular region. Prior to joining SJAFCA, Chris worked in various roles at the Santa Clara Valley Water District for 17 years and at the Silicon Valley Leadership Group for 3 years. We also have Alicia Kirchner. Alicia Kirchner is the chief of the Sacramento District's Planning Division for the U.S. Army Corps of Engineers. For over 30 years, Alicia has conducted complex feasibility studies and environmental reports, leading to congressional authorization of a broad array of projects, largely in California. And last but not least, my colleague, Gary Lipner. As Deputy Director at the Department of Water Resources, Gary advises and assists in the formulation and implementation of policies and programs within the Division of Flood Management and the Division of Safety of Dams. Gary is a key advisor to the Director and other executives on major public safety policy, program, and operational issues. Let's give the panel a brief round of applause. All right, let's jump right into it. First question I will put to you, President Dolan. President Dolan, I'd like to begin with you as highlighted in the forthcoming update to the Central Valley Flood Protection Plan. This region is among the nation's most flood vulnerable landscapes. According to our climate analytics, significant flood flows in our Central Valley rivers will likely increase several times over in some areas and during larger storms, quickly surpassing the capacity of our current levee systems. Adding to the complexity, of course, the population of Californians living in floodplains protected by our levee systems is expected to grow by over 400,000 in the coming decades. To help counter these increased risks, the new flood plan will call for an investment of at least $25 billion over the next 30 years. Jane, you've lived in the middle of the flood system, in particular the Butte County flood system for your whole life. That's right. You've been on the Central Valley Flood Protection Board for over a decade, and now you are its president. How have you seen flood management in the Central Valley evolve, and how is that evolution reflected in the forthcoming 2022 update of the Central Valley Flood Protection Plan?
Thank you, Chris. Thank you to everyone who's here today in the room and online. What a very informative, energizing session so far. You are correct. The plan is just that, an evolution. We know that it began with very important legislation when the legislature reflected upon damages and danger and lack of investment throughout the state and made actions of reorganization and directed that there be a first ever Central Valley Flood Protection Plan, which was adopted in 2012. And with each of the updates, the one in 2017 and the one that's before us in 2022, the plan is continuing to be based on science, information, and collaboration. Prior flood planning and management seemed to address changes and just maybe keep hoping for the best. But now we have more specific information that will give us a direction on how to move forward with a Central Valley Flood Protection Plan that meets our changed climate and the needs of our residents. The 2012 effort was indeed groundbreaking, and we have continued to learn, reflect, and improve upon it. And we are happy to know that the legislature is at least beginning to understand the need for resources on an ongoing basis and not just after damage to improve and our aging system of protection. Many projects have been done in the last decade plus, and many parts of our system have been improved, but there is a substantial part of the system that is more than a century old and needs to address our current standards and needs. Instead of planning for a flood system that always was from October to February, we don't have a week of flood preparedness anymore. We have an ongoing flood preparedness. We are communicating more. We have established ways to communicate, talk with each other, not just at each other, so that we can face together the real challenges of protecting the life and infrastructure of our Central Valley. We learned that if we just react to an occurrence that occurs, move to improve damage, try to help people, and if we implement just piecemeal projects or part of the system without looking at it as a whole, in fact, from watershed to the valley, then we leave a lot of other benefits left on the table. Over the last 10 years, and now that we're getting ready to adopt the third update, we will look to our historic floodplains for opportunities as we must revise our flood system to address the changes that are upon us and have better management and coordination among all water sectors. We have a real sense of urgency, certainly improved today, as we have seen what has happened across our country. We know that there will be intense storms. We just don't know where or exactly when they're going to happen, but we're improving on that forecast as well, which is good to know. We need to widen our riverways and floodplains. That will help indeed be a central theme in this plan to address the management of our system, to address the flooding issues that will be and have changed, and to protect life and infrastructure. Of course, the focus is always on protecting people, but we also acknowledge that environmental improvements and ecosystem uplift are an important part to allow species to recover and thrive, and indeed to attenuate the benefits that can come from arc storms, and to address to the extent that we can in this highly developed world that we live in, the benefits of ecosystem to assume flood capacity for our area. This is an avenue also for improving conjunctive use and establishing that, and perhaps be part of the important effort of recharging our depleted groundwater basins. We know, and we have put in our plan, that we need good partnerships with agriculture. They do have and sit in our historic floodplains. And we need to understand that there are many opportunities to work together. I view it as both habitat-friendly agriculture and agriculture-friendly habitat projects. And of course, we will look at potential recreational opportunities. The flood plan updates and addresses the very real essential issue to address equity and assistance for small communities that do not have capacity to do the things that we ask them to do or they want to do. We need to fix our aging system, and we need to protect these small communities in the rural areas. They are a vital part of our system, as is our intensely urban areas. Our plan acknowledges that we must do this and suggests ways that we can ensure equity and social justice and have it be an intrinsic element of the Central Valley Flood Management System. And let me just also say on behalf of my board and the Central Valley Flood Protection Board that was identified to be independent and more active, that we provide a very valuable public forum for these discussions to occur, not just at our monthly meetings that are primarily in person now, thankfully, but also very importantly hybrid. And we continue to work on the sound and video system to assure that that can occur. And it allows us to come together, tribal communities, our flood management communities, our local maintaining agencies, local officials, state officials, and just plain people who are interested and have an idea to discuss. So we have several forums and several meetings to do that. And we think that's very important, and we will continue to stress and be active for that. We partner very closely with the Department of Water Resources for all these things that we hope to do. The department presents the plan, and the board has the hearings and ultimately adopts that, and together we will do it. So what's changed from my history to what we're doing here on the board? We collaborate, we talk with each other, we listen, we respond, we make changes as we need, we try to be flexible. That has allowed us to do what I think this 2022 update will be a very inclusive, forward-thinking plan. So what effort we need to do from this point on is to implement it and to increase our pace of implementation. Thank you.
Thank you, President Dolan. Just a quick follow-up. John Kane, to you. You've been a participant in the Central Valley Flood Protection Planning process for the last couple cycles since its inception, I believe. And your perspective is, of course, different than that of government per se. So curious, from your perspective, as you see the emergence of the almost now final 2022 update to the plan, what do you see as some of the most provocative or maybe urgent, more appropriately, discussions that are going to be sparked from that document? And anything along those lines would be great.
Well, I would say the most provocative, perhaps the most provocative thing is the cover photo of the plan. And Jane, I believe, or I should call you President Dolan, I thought I saw you with a hard copy. If you were interested in, we don't have to get it. There it is. She carries it with her everywhere, brand new as of Friday. And it's so much different than the cover photo of the 2012 plan, which was a perfectly engineered barren levee. And the cover today is the Dos Rios floodplain multi-benefit project. And I think it's really a recognition that we need a broad portfolio of flood risk reduction measures, starting with land use, smart land use, emergency response, building codes, flood insurance, very important for economic resiliency, levee improvements where cities have already been built, and then something that's just really compelling and exciting to the flood management community is multi-benefit flood management projects. It's really evidence of a broad consensus in the flood management community. We're working really quite well together. Many of us were at an event celebrating the Dos Rios project last Friday. We're here today, and then we've got a couple field trips. And this is a community-wide group of stakeholders that didn't always get along. And I think a lot of the reason we're getting along is the leadership of the board and various stakeholder communities that created a broad umbrella for us to think about what we're trying to do under the flood plan. And we call these the 5 societal goals or the 5 societal values: public health and safety, ecosystem vitality, economic health, enriching experiences, and equity and justice. And when you think about flood planning that way, who doesn't want to be involved in it? Who doesn't want to be a part of it? So what's the most urgent thing? How are we going to pay for this?
Thanks, John. This one's for Alicia. Alicia, you're the Director of Planning for the Sacramento District of the U.S. Army Corps of Engineers. The Army Corps is a critical partner in the state's efforts to implement the Central Valley Flood Protection Plan, of course, which we are grateful for many reasons. And one of those reasons, not the least of which, is that you and the district have helped bring over $7 billion of federal appropriations to California over the years. Projects throughout the Central Valley and beyond have benefited from that work and those collaborations, including recent significant modifications to the Folsom Dam, which is just upriver of us here on the American River, and protecting the downtown community and the broader region, of course. Here in California, the Army Corps does a lot of flood and other water management projects in partnership with state agencies such as the Department of Water Resources and the Flood Board and others. But from what I understand, that in some ways it is a unique situation when compared to other dynamics and relationships between the Corps and projects in other states. In other states, from what I understand, much of your work is done directly with local government and without much state engagement per se. What is having the state of California squarely at the table with you in decision-making in the process, in your interactions with local government that has allowed your objectives to have maybe been met in different ways, but I would hope in an accelerated fashion? How is that dynamic different from your perspective, and what does it add to the conversation?
Thank you. Good morning, everyone. Yes, that's very true. The Corps of Engineers Civil Works program has a requirement that we work with non-federal sponsors and cost share, both federal and non-federal, throughout the whole project development process. Different rules at different points in project development process. But in the state of California, we've got in Central Valley, particularly, we have an existing flood management system that Congress made federal a long, long time ago. And as such needed a non-federal sponsor. And the state of California organized itself many, many years ago to serve as that non-federal sponsor, that owner of that federal project, federal flood management project, and has the responsibilities of operation and maintenance of it. And that existing flood management system of the Central Valley spans hundreds of miles, right? Hundreds of miles of levees, bypasses, weirs, crossing many, many, many local jurisdictions, towns, communities, counties, north, south. And to have non-federal partners for something of that magnitude at an incremental local level would be very complicated and probably not very efficient. The state of California serving as that sponsor in that very critical role is able to really work with the Corps of Engineers and with local agencies up and down the system as we work to make significant, though incremental modifications to what is a bigger flood management system. The state also serves as a regulatory entity, watching to make sure as others seek to make modifications to the existing flood management system, that the modifications are sound. And fundamentally having the state as that common non-federal denominator throughout the existing system really helps to ensure that the integrity of the system so that the system can continue to do its best from top to bottom. I would say another key aspect of having the state in that non-federal role, there's a lot of projects in the Central Valley that we're involved with that are vying for federal dollars. And that's true across the country. So in the annual funding quest for, seeking federal dollars to go into local communities for these projects, it's tremendously valuable that the state of California has a plan for the Central Valley and that all these individual projects are not random. They fit into a bigger vision and deliberate initiative that the state of California is able to have pulled together and messaged. And that's very compelling for the federal government when it's looking to allocate funds to projects across the country. So we fare well for the projects in the region. So that $7 billion that you mentioned, Chris, we get to that in this area. It's currently about that much of project value and design and construction phase now because of the federal, state, and local partnerships up and down the valley that have come together and been able to really leverage, as Mark mentioned on the first panel, these projects modifying the existing flood management system and creating new systems are expensive, right? High value infrastructure projects. So being able to leverage all three levels of government, federal and state and local, is really the best way to collaborate, come together, and leverage all those resources to be able to make these improvements. And maybe lastly, having three parties involved, sharing costs and working together on developing these projects, it's probably lends itself to conflict and issue resolution. At a minimum, that's a tiebreaker if we hit some challenging project issues. Thank you.
Yeah, thanks, Alicia. So you mentioned that third partner, so of course, local government. So I'd like to turn now to Mr. Chris Elias. So Chris, you're the director, the executive director of the largest regional flood management agency in the San Joaquin River system. You heard President Dolan earlier describing the big picture strategies of the Central Valley Flood Protection Plan, and you heard John and Alicia give their perspectives on similar. But from your perspective, what are the challenges facing your area in the coming years of climate extremes, some of which we heard about in earlier panels and keynotes this morning? And what do you see as the most critical issues to focus on to improve flood management for the people living behind the levees in your region?
Good. Thank you, Chris, and really a great honor to be here this morning to be with the esteemed panel to address a critical issue that's of great importance to our community, San Joaquin Basin. So as I'm translating your question to be basically, what are the challenges we're facing? And I'll capture them in that they kind of belong in three buckets. So first is that the San Joaquin River system is very unique in the sense that this covers about 300 miles, more than 300 miles of river that kind of making its way all the way down to the to Stockton metropolitan area, which is the bottom of the barrel, basically. And it's unique because it has very limited capacity in the channel itself as the water is making its way, to heavily urbanized corridor, of the basin. And so with climate change, as the flow increases, the channel obviously isn't sized sufficiently to capture or be able to manage the flow. Let me give you an example. The current Central Valley Flood Protection Plan that's been released in it shows that that we are facing an inordinate amount of increase of flows. When in 50 years from now, 200-year level of flow is at about 200,000 CFS, and then the projection is that the estimate right now is that we're going to be looking at about on high end 640,000 CFS. That's huge amount of increased flow. And the channels cannot be sized up big enough and tall enough to handle that flow. So that presents some opportunities itself. So that's first. Second, the second aspect or challenge we face is from sea level rise. That's also the projection we are right now in the Delta. So we are facing a challenge of sea level rise that in the next 30 years or so, we're going to be looking at about a foot increase in the sea level that's coming toward the community. Not only toward the community itself as people, but also infrastructure, then also as well as the impacts on water quality. Pushing back obviously on causing some seawater intrusion that may well impact in the groundwater basin for water supply. And then thirdly, from what we heard earlier on today, the frequency of precipitation may not be the issue, but it maybe is the intensity. And with that kind of intensity, we are basically at the bottom of the barrel. And on our east side, we have headwaters that may have runoff that could overwhelm a reservoir system that is serving as a water supply infrastructure. That if it gets overwhelmed, that wall of water would be making its way to the Stockton metro area. So in that basin, we're looking at about 300,000 people that will be basically facing the threat or risk of flooding, both from inland drainage, sea level rise, and the runoff from the main stem of the local San Joaquin River. So if we do have a breach in the system, so it's going to be catastrophic. And that's a challenge that kind of keeps us all awake at night when we reflect on the learnings we just heard today about level of precipitation that could occur, could come to the system and impacting our people. So what are we doing about it? We've been very fortunate to work with great partners that we have at the table today, both the state and the federal government, to start putting in place pieces of solutions. So first, one of them is we're looking at Paradise Cut as one way to look at, we're relieving the valve of allowing the water to kind of keep the channel, but in a managed way. The Paradise Cut is a project that's under study that we're in partnership with the Department of Water Resources. It's just kicking off and is in the planning stages right now. So that's first. And it also touches on the comment that President Dolan made earlier on about looking for a way to basically engineer with nature. And this is an opportunity that Paradise Cut presents for us, not only in the area of ecosystem restoration and we can take care of both aquatic and terrestrial habitat, but also managing, being able to recharge the groundwater basin in an area that has severe deficit in our groundwater basin because of critical overdrawing on the basin for many, many years now. And then we also have the work that we're doing right now. In fact, it was just 2 weeks ago that we signed a feasibility cost share agreement with the U.S. Army Corps of Engineers to start looking at the upper part of San Joaquin, looking at a way again to put in a study that will help us right size the levee system again to protect the heavily urbanized population. And finally, with respect to sea level rise, we're building the Smith Canal Gate project. This is a project that is co-funded by the department and also and that is in partnership with the Corps because eventually they'll be coming in as a partner into the project, again, to ensure that that our community is protected from sea level rise. But I do want to make a point that one common factor amongst all of these sources of flooding is that we have a heavily disadvantaged community at the bottom of the pool. And all that wall of water will be coming toward them, whether it's from the main stem, from the inland drainage, or from sea level rise. And we are working with all our partners here at the table to find ways and design solutions, that would help us to prevent, adapt, or mitigate to the greatest extent we can for the safety of our community and as well as the businesses and environment we are serving.
Thanks, Chris, and I appreciate you raising there at the end, really throughout your comments, just that it's a very sobering fact, to put it lightly, too lightly, that in far too many instances, and certainly disproportionately, it's those communities, those historically underrepresented communities that are oftentimes most at risk, and not only to flooding, of course, but to other water-related challenges, both historical and ongoing. If you would, Chris, if you have anything else to expand on this, I would love it. If not, that's okay. But you mentioned in your comments that your region is not only, of course, highly flood prone, with a disproportionate level of flood risk to certain communities, but you're also, just like the rest of the state, suffering through a pretty difficult drought period, again, to put it all too lightly. Can you talk a little bit about the intersection in your world between flood management and long-term water supply resiliency and any of the strategies that either SEJAFCA, maybe some of your partner agencies are pursuing that really does dissolve that historic boundary between those two conversations and starts really merging them?
Well, great. Thank you very much again, Mr. Chanel, for that question. One of the key benefits of having all these intersectional challenges is you get to look for solutions that are kind of cross-cutting. And one of the things we are looking at right now, obviously, is that we treat water as one water. Whether it's too small or too big, meaning flooding to drought. So we'll try to find a way to use the excess flows in the main channel or in the reservoirs to drought-proof our water supply system and protect the people at the same time. So we are in collaboration with the department on what is called the Calaveras Watershed Study. What that study is doing is to enable the department and our local stakeholders, flood protection interests, water supply interests, as well as the community at large, to start looking at ways now to, in the event where to have those huge flows coming down the runoff coming through and overwhelming the reservoir, what should we do downstream? So we are working with the department to start doing a study to find a way then to implement some of the tools we just learned about today, filters and flood more, so that you can manage the water from headwaters to groundwater. essentially finding ways to, that if you're able to do that successfully, then that reduces the amount of water that will be heading on the channel to reduce the flood peak that will be hitting our community. So we are enthusiastic about the promises of both FIROMAR and FloodMAR to the extent it can be part of the solution or tool sets that will be made available through this Calaveras watershed study. And we're very delighted that the department has taken the leadership after so many years of bringing us together to find a way to implement and apply some of these evolving technology to help us manage the water, but at the same time, drought-proof our water supply system and protect our people.
Thanks, Chris. That's wonderful. And it really brings me back to the previous panel where at the end, at least, there was some discussion as to what comes next for FURO, what's FURO 2.0, and it was mentioned that it's more of an evolutionary step than anything less than that. And what I'm hearing you starting to talk about here is really exciting, and that is, let's look also downstream at increasing capacity, in this case, opening up our groundwater basins to receive some of those floodwaters, and thinking very critically about what that might allow us to do with reservoir operation, downstream communities, both underrepresented and otherwise, and at the same time, reducing flood risk and bolstering our long-term supply security. So pretty exciting work there. Yeah, thank you. John Kane, to you. For many years, you have championed flood management projects that have incorporated nature-based solutions. Lots of different ways to say that, but that's certainly one of them used these days, such as widening rivers and expanding natural floodplains. I think it's safe to say that 20 years ago, these approaches to reducing flood risk were seen as maybe academic at best, and at worst, untested and expensive or too complicated. But today, I think it's also fair to say that it's a rare flood management conversation that doesn't include mention of these multi-benefit quote unquote projects or nature-based solutions or engineering with nature, which we'll get to in a moment here. Can you talk a bit about the types of projects you see as critical to addressing both flood management and these other public values? And I think you might have mentioned an example earlier, but anything else you wanted to add to that?
Yeah, thank you. How we talk about it in the conservation community, and starting at the 2012 plan, was the 2012 Central Valley Flood Protection Plan, was that public safety is the #1 priority when it comes to river management, and giving rivers more room is the best way to keep our communities safe from flooding. And I'm happy to say that the Central Valley Flood Protection Plan now really reflects that. And even the governor is calling for expanding our floodways, particularly in the downstream portions of the valley. So we have plans to expand the Yolo bypass, and I've been working with Chris Elias and Sajafka to expand a new bypass at Paradise Cut on the lower San Joaquin. And what's important about giving our rivers more room is that when we give them rivers more room, we get multiple benefits out of that. And one of the best examples of a project that's virtually complete, nearly complete, of a multi-benefit flood management project is the Dos Rios floodplain restoration project at the confluence of the Tuolumne and San Joaquin rivers. We just celebrated our 10th anniversary there last Friday, and the project is fully planted out with native vegetation, but the benefits are much wider than habitat. It attenuates peak flood flows. It reduces water demand because we replaced irrigated crops on the floodplain with native vegetation, which uses about 60% less water. We get groundwater recharge out on the project when it floods, significant water quality benefits. Carbon sequestration, well supported in the literature, how much carbon sequestration we get from the very types of projects that River Partners does to restore riparian forests in the Central Valley. Open space and recreation. One of the big announcements we made last Friday was that Dos Rios will be the next state park, the first state park named in 13 years in the state of California. It also helps agriculture. It turns out as soon as we bought that project, our neighbor said, hey, I would really like to get out of the floodplain too. My dairy is at risk. And the down payment we were able to put on that allowed that landowner, our neighbor, to put a down payment on a dairy on higher ground, and his business is much healthier as a result. And of course, habitat for fish and wildlife. But to really realize another reason why Dos Rios is a sort of a worth focusing on here is that to really realize the benefits of projects like Dos Rios, we need to do it at a greater scale. I heard someone from DWR that attended our conference, our event on Friday, we need to do 50 more of these. And when we do them at a larger scale, we get a lot more benefits. We let rivers be rivers. They'd be much better at cleaning up water as water is forced through sandbars. And then very importantly, it increases reservoir flexibility. If we have a wide corridor from reservoir all the way down to the delta, which we're starting to build, we have more flexibility in how we manage the reservoir. And I bet you the FIRO people are going to be happy about this in 10 years when they need to adapt again and again, and we have more room there for them. I want to close by saying that Dos Rios is also a model in how it was implemented. Gilbert Cosio is back there in the room. I remember him 20 years ago saying, if we want to do more restoration, we need to route money through the reclamation districts. And that's exactly what we did at Dos Rios. We included a nonprofit partner, River Partners, on that. We have lots of partners, multiple state and federal funding sources bringing together on one project. That's the new thing that we're going to have to figure out how to do. And DWR and the Flood Board really welcomed a new stakeholder there and young leaders. They asked River Partners to be the lead of the regional flood management planning process, along with the local reclamation district. And Julie Rentner, the president of River Partners, got her start as a young leader. And I just have to say she's an exceptional leader, and she's ready to do another 50 Dos Rios. Thank you.
Thanks, John. Alicia, just down to you briefly, just 30 seconds or so, if you could just describe some of the work, the innovative work that is coming out of the R&D program at the Army Corps of Engineers, coined Engineering with Nature, and anything that folks should know about that if they want to follow up to learn more about it.
Sure. So the Corps has a program actually that has a lot of initiative behind it right now because of the administration's priority for nature-based solutions, called Engineering with Nature. And it's run out of our Engineering Research and Development Center in ERDC in Vicksburg, Mississippi. And it's led by Dr. Todd Bridges. He is the Army's lead scientist for environmental science. And Engineering with Nature fundamentally is the intentional alignment of natural and engineering processes to deliver economic, environmental, social benefits efficiently and sustainably through collaboration. And it's really sort of a mindset and an approach to any kind of infrastructure, either development, modification, contemplation, whatever. We're really challenged and encouraged to think of it as a lens we look through in all aspects of the Corps' missions, including our military program, working with installations. Fundamentally, for someplace like the Central Valley, where we have an existing flood management system that we contemplate making these modifications to, it's really about looking to see how we can utilize, first and foremost, thinking about more nature-based solutions so we can have that compatibility. It's a really short, bad commercial for what Engineering with Nature is, but if you'd like to learn more about it, you can go to www.engineeringwithnature.org, all one word, and it will take you to a Corps of Engineers site that has a much harder web address to remember or say.
Thank you, Alicia. Okay, Gary, I want to direct this last question to you, and then to the extent that there's time, maybe invite just a little bit of a lightning round, folks going down the panel to also weigh in on this. We've heard from a number of different perspectives this morning: tribal government, state government, federal government, local government, academia, the private nonprofit sector. A lot of good work is being done in the face of climate change, and a consistent theme, it seems, across all of these discussions is the importance of partnerships. So I would ask you, from your perspective, how are we doing in that realm? How are we doing in the partnership formation world? And what kinds of projects and progress are you seeing that's being born from those relationships?
Yes, thank you, Chris, and thank you all for participating today. I think we're doing well at offsetting the effects of climate change, and we're doing a great job on expanding our partnerships and providing good projects. That said, it's the rate at which we're doing them that is a little nerving, because climate change impacts are increasing fast, and we absolutely need to increase the pace and scale with which we're advancing our mitigation to climate change. It's almost like good news, bad news. The good news is we know what to do. You've heard a lot about it today. The bad news is we need to get there really quick, and we need to advance it really quick. And we need, in doing that, absolutely, we need to do it with expanded partners to have the projects move along. Jane covered the Central Valley pretty darn well. So I thought I'd share a few statewide efforts, what we're doing within the context of addressing climate change. And, you know, one key that was talked about today is flexibility. To become climate resilient, we have to add flexibility to the system. Climate change impacts are altering the timing, pace, and scale of the weather patterns and when we're getting water and how we're operating and managing it. We've heard about it today at great length, and we understand that. To, you know, help with flexibility, we've made really good progress on data and forecasting management system to aid our water managers and to provide more time and more accurate forecast for improved operations. So at the department, we've utilizing an innovative tool, ASO, Aerial Snow Observations. It came up in panel 2 to improve our forecasting, such that this innovative tool of ASO allows an entire spatial grid of the entire snowpack, as opposed to the representative snow courses we used to use. So it allows for forecasts that have are much more accurate moving forward. And we're using that innovation, and we're hoping to increase ASO, the pace and scale, the number of watersheds we could fly over in the given year, and how many times we could do that in that really short window, whether of winter, of 3 months, of 2 months, of when we're getting those atmospheric rivers that California depends on us to manage well in that very short time. So that's a great innovation that we are moving forward with. We also are adding system flexibility by adding multi-benefit approach to flood project. You know, climate change is forcing us to look at projects with a more holistic approach and benefits, as opposed to a single flood risk reduction benefit. We need system flexibility in the projects we're advancing to handle the extremes we're seeing. The big flows on one side and the smaller flows to be able to get through the year. So our approach is, it's not just about flood risk reduction on projects or water supply. It's about flood risk reduction and water supply and ecosystem uplift and recreation. We need to expand the benefits we have of projects. And in doing that, we need to expand the partners that we do. And we have done that, I think, and we need to continue to do that. When you expand the benefits of projects and you expand the partners of project, you have more advocacy. You have less resistance for the project. You have less litigation of the project, and you might have, and often do have, alternative fund sources to round the corner to have a more holistic project move forward. So partnerships and multi-benefit are key, and really add system flexibility in managing the extreme conditions that we are seeing. Want to share a little bit about projects. A project that hits the mark very well on this, it was mentioned earlier by Mark Strudley, the Paro Flood Risk Reduction Project. It is a flood risk reduction project in 2 highly underserved communities, the towns of Paro and Watsonville. And the project advocates, the locals, just got together through great partnerships and designed a great project that has flood risk reduction, also has ecosystem uplift, also has water quality, also addresses groundwater recharge and recreation benefits. There are so many benefits that the state, and as well as the project, serves a severely unrepresented community, that the state found an innovative solution to fund 100% of the local cost share. And the state found an innovative solution to advance our DWR subvention funds to take care of early project requirements early in the project. So it's a great solution of that multi-benefit through partnerships and what we could do together. Can we do 50 of those projects, as John Kane would say, across the state, though? That's the question, and that's what we need to increase with the pace and scale. So moving forward, I think where we really need to go, and we've talked about it today, wrap this up real quick. Flexibility, we need system flexibility, we need to better address equity, and we need to stay prepared. We need flexibility to come by looking holistically at the watershed system instead of just the project footprint, and having more multi-benefit projects that forces us to integrate better across the wide spectrum of partnerships that we have. We need to adapt to our changing climate with flexibility in the changing in how we observe and do forecasting. And we heard a lot about that. We know what to do. We just need to put it in play and get it operationalized, the R to O, and do it at a quick pace and scale. And then equity, we need to address equity better. We are addressing it, but we need to increase how we address it to help the underserved communities and their needs, understanding their needs, as well as advancing innovative funding solutions to help support